Hello everyone and welcome to yet another recreation programming session with Ahu Amisa Azozin. I have this library that for some reason is very useful, right? I didn't expect it to be useful. I just slapped together some idea, and then over time I realized that I actually tend to go back to this library and copy paste it into my projects. So it's a very cool library. It's basically an implementation of Arena Allocator. You can find it in here. I'm going to copy paste it in the chat for people. In the description is going to be on YouTube. And what's interesting is that, so if you don't know what is an Arena Allocator, let's actually take a look at Arena Allocator. At a high level, it's sort of like a place into which you can allocate memory, right? So you can essentially say, okay, so I have Arena, default Arena. And then I can say, okay, allocate memory into that arena. Then I can put another arena, and I can allocate memory into that arena. And these are two separate memory spaces. And one of the important operations that arenas have is deallocate all of the memory allocated with that arena at once. Right. So why this is cool? So one of the problems with C, as something that actually gives C a pretty bad rep, is what I personally like to call something like a malloc free chasing, right? So malloc free chasing is a bane of C's existence that absolutely fucking ruined the reputation of C, and it very much doesn't have to. It very much doesn't have to. So essentially, it's the idea that when you allocate memory through malloc, you should never forget to have a corresponding free, otherwise you're gonna have a memory leak, and memory leaks are bad because my professor told me so. Right. And it's just and because of that, people who program in C, they wanna fucking die because, oh my god, I forgot to call corresponding free, my professor is gonna kill me, oh my god. And then some very funny individual with a very long legs come along and gives you classes with distractors that automatically destroys objects at the end of the scope, and you think, holy fucking shit, we have to move to C++. So essentially, we created a problem so then we can have a solution C++. But that solution gives you even more problems, so you're trying to solve them, and eventually you go to things like Rust, but that's besides the point. So you may start with actually reconsidering this entire paradigm, right? So this entire chain of solutions for problems, solutions for problems, solution for problems started from here. What if this entire thing is kind of a wrong premise? How about that? What if we just allocate throughout some particular operation, allocate as much memory as we want, without thinking that whether we have a corresponding free for that object or not, just put as much shit into that specific place as possible, and once you're done and you know for sure you don't need any objects in that bag that you throw it in, just throw away that entire bag. That is actually much easier to think about than chasing mallocs and frees and stuff like that. Obviously, this kind of approach is not perfect. It is not perfect, it's not suitable for everything, but for a lot of situations, it is actually pretty fucking cool. And in some situations, it even feels like you're programming with a garbage collector. Right. And what's funny is that you can think of arenas as very dedicated lifetimes. Right. So you know how in Rust, lifetimes are basically part of the type system? Right, and the compiler at compile time tries to make sure that object lives, so you're not trying to access objects that live too short or outside of their lifetime and stuff like that. So here, Arena is a separate lifetime, and you decide when objects in that lifetime are gonna disappear or gonna, go expired or die. So this is basically what arenas are, right? And I use them all the time. They're very useful. How they're usually implemented? That's a very interesting question. My mouse died for some reason. I don't fucking know why. Chat, what the fuck is going on? Bro, how my mouse died? I'm sorry. While I was yapping, my mouse has died, and I can't even use it anymore. And I can't even live without the mouse. Okay. Alright, donate me for a new mouse because this motherfucker doesn't work. So keyboard works, right? Keyboard work, but mouse that does. What the fuck is this shit? Keyboard only stream. Yeah, that's probably what we're gonna be doing. I only recently bought it, so I swear to God, the mouse manufacturers, they're actually making them so they die very fucking quickly. So then you go and buy a new one or something like that. So yeah, my mouse is dead apparently. So we're doing that without the mouse. Okay. At least I have a touchpad. Okay, so I'm actually streaming from a laptop, so I can just use a touchpad. Well, I mean it works. I'm using a touchpad. Okay, so I can just like put it in here. Like, yeah, so that's how I can do that. But my mouse, my external mouse, doesn't work. So touchpad exactly. But it's kind of inconvenient, like, because sometimes I want to move with the mouse like a Windows and stuff like that, and it's very much fucking a pain in the ass. And it's just like, how am I supposed to even do that? Like, I don't even know. Maybe I can, yeah, I can probably do something like that. So I want to be able to do this kind of thing. So I bought somewhat expensive Logitech G mouse long ago, and it still works. Yeah, that's kind of interesting. So for some reason, like every mouse I buy, it just dies within a couple of months, for whatever reason. So, anyways, how do you usually implement arenas? So we can maybe take a look at the source code of this entire thing. Do I even have arena? I don't even have arena cloned. So maybe the time has come for me to practice, you know, mouseless UI, right? So basically using tabs and Control Fs and stuff like that. So as you can see, I'm using tab. I can copy URL, and then in here, who needs mice? Just think about that. Who needs, like, I just copied the URL without mice or anything. So then I can do quick clone. Fuck mice. Fuck mice. All right, so here's the arena, and let's take a look at the structure of the arena. So it should be, yeah, here it is. So what's funny is that the arena internally is just two pointers, begin and end, and they are pointers to a region, something that is called a region. So a region is in fact a linked list. See, it refers to itself, a linked list of chunks of data. So that's what it is, believe it or not. It's a linked list of chunks of data. So essentially, how does it work? You want to allocate something within an arena. It uses internal allocators, sort of like a backend, right? So it's not an allocator of in itself. It needs another allocator to allocate it chunks for its linked list. Right, so let's actually say that a single chunk is going to look like this, right? So we allocated a region of memory, so this is the chunk. So at the beginning of the chunk, as you can see, we have a pointer to the next, right? So this is basically next. Then we have, I suppose, how many bytes we already allocated within that region. And I suppose the size of that specific region, right? So the size of that specific region is going to be capacity. So we have like three numbers in here, and pointer to the next chunk in here is a number because it's an address. Right, so and then if we ran out of the memory within this chunk, we just allocate another one, and we make next point to that one in here. Right, so next points to this one. And then if we need more memory, we allocate another one, and then another one, and then another one, and this is our arena. Right, so and how do we even allocate memory within the chunk, right? So essentially you want to allocate maybe this amount of memory, right? So this amount of memory, we use counter to keep track how much memory we already allocated within the arena. So we just append to the count the size of the object you want to allocate, and then we just place that object in here, right? So we're going to place something like A, there we go, we place that object in here. Then we want to allocate another object, we add the size of that object to the count, and then add the counter to here, and then just place that object in here. So we're going to replace this stuff with that stuff, and there we go, and so on and so forth. So that's how it works. You ran out of this specific chunk, you go to the next one, and the next one, and the next one. So you may ask, why don't you just use reallocate? Like, why do you make linked list? Why don't you just use reallocate? Right, so essentially realloc allows you to extend allocated chunk of memory. The thing about realloc is that it does exactly what it says. It reallocates the chunk of memory. So essentially, it does not magically just gets more memory. What it does, it literally allocates a bigger chunk of memory in a different place, copies the old data to the new one and returns you that new chunk of data. So if you hold any pointers, I forgot that my mouse doesn't work. Fuck. If you hold any pointers to any of the objects within your arena, they're gonna get invalidated immediately, right? So because of that, to keep the addresses of your object stable, we do not reallocate anything. We allocate the next chunk so they stay pinned in the memory in a single place. So that's why it is implemented like that. Right. So that's basically like a Arena Allocator 101. Right. So, and it is implemented exactly as I just described, right? So you can just take my description and just put it as a code and you're going to have Arena Allocator. So it took, yeah, roughly 378 lines of code, which, yeah, I think can I use arrows? I remember implementing sort of like an arrow control for my boomer for zooming in, but it doesn't work anymore. You know what's funny? You know what's funny is that the mice, like it has its thingy, right thingy working. It just doesn't send any information to the PC. So which makes me wonder maybe there's something wrong with my USB hub or whatever. But I mean, I don't know. Something with the driver. Yeah, maybe something with the driver. Other port, I tried to put it to another port, but it didn't work, unfortunately. Linux experience, maybe it's because of Linux. Who fucking knows? Who fucking knows? So yeah, so we got some subs. Thank you so much, Keldalin, for gifting community sub, and Dr. Love Wizard. Thank you so much for the sub. Thank you. All right. So here's an interesting thing. We have several backends implemented for our arena. So by default, it uses malloc to allocate these specific regions, right? It uses malloc. So, but then if you don't use the standard library, right, you may want to use a low-level API. For example, on Linux, you can use a memory map if you want to. Or if you're on Windows, you can use virtual alloc. So, and I think different people at different times basically contributed different backends, and we do have backends for memory map and for virtual alloc. And I also have a stub for WebAssembly, right? So because maybe in the future you want to actually port your code to WebAssembly, and your code uses Arena. So in that case, it would be kind of nice to have something for the WebAssembly, but it's not implemented yet. So, and the topic for today's stream is essentially, can we implement, WebAssembly backend for this entire thing? I think it's going to be interesting, right? Because I have a project where I would need that soon. So yeah, I decided to take that as an opportunity to make a stream where I'm just like, implementing basically a WebAssembly backend for my Arena allocator. Sounds good? Sounds good, Tamaguchi. Let's fucking go. So to implement this entire thing, I think we need some sort of example that uses Arena allocators. Right, so I wonder if we can actually maybe grab this example, but this example is not that great. So one of the good examples for Arena allocators is parsing trees, right? So, and this is one of the reasons why Arena allocators are so popular in compilers, right? Because they allow the compilers developers to just like, when they're parsing, allocate as many tree nodes as possible, right? And without thinking to deallocate them or whatnot. And then when they're done dealing with a tree, they can just deallocate everything at once. Right, so maybe we're gonna do something related to trees. Maybe we're gonna can implement like a simple expression parser. Right, so we're gonna implement it for native code, and then we're gonna try to port it to web and see if it works in web. So we got some subs. Thank you so much, Doruk Sega, for Twitch Prime with the message. Watching your code motivates me to do so as well. Thanks, you're welcome. That's exactly my goal. That's exactly my goal. This is why I'm streaming, because I think programming is fun, right? And I want I want to motivate people to do programming more, right? So because programming is like a video games, kind of similar to Minecraft, right? So you build in your project, and to be fair, when I'm building my project, it gives me similar feeling to building a base in Minecraft. I actually keep comparing these two activities. They're kind of similar. Right. kind of similar. But anyway, so let's actually maybe create some example. Expression.c. All right, so this is going to be expression.c. stdio. We're going to include the arena allocator, right? So there you go. And I'm also going to define arena implementation because it's a STB style single header library. So that means this header contains, why are you so bright yellow? Right, so Emacs, when it has like a training new lines, it just like gives you bright yellow that burns your retina. Right, so it basically acts both like header and C file, so it contains declarations and implementations. So if you include it without implementation, it will only include declarations, right? So to make it include all the implementation, you have to do something like this. Yeah, so the standard thing, so it's called STB style. Opa, STB style. Ugh. So what we're going to be doing in here, I think we can maybe implement like a very much simple expression parser where we can have operations like multiplication and addition. And let's not think about tokenizers too much, right? So let's not tokenize anything. And let's actually don't do any, how is it called? Any precedence, any priority or anything like that. So because of that, all of the binary operations has to be wrapped in parentheses, right? So because we don't really know the precedence of this entire thing, so you have to wrap it like that, right? So so if you put any spaces, this is going to be invalid expression. So we do that just to save some time, right? Just to save some time. We could have employed you know, our Lexa. We actually do have Lexa. It's called Alexa. Right, this is called Alexa, but I know it's kind of like not really great on its own, right? So I think it's just easier to consider maybe each individual character as a separate token. So get some sub. Thanks so much, the Frankie Joe for Twitch Prime Kitchen with a message. As a network and system administrator now interested in system programming, thank you for making this kind of content. I'm learning so much and really appreciate it. You're welcome. What's funny is that I've kind of done too much corporate programming to the point that I want to become a network and system administrator. And ironically, I'm not even fucking joking. I kind of want to be a system and network administrator because after doing programming for almost 20 years, I'm not exactly 20 years, I think it's like 18, 19, but almost 20 years, I have a strange feeling that the job of a programmer is to create problems for system administrators to solve. And I kind of... And I'm kind of get tired of being on the end of creating problems. I kind of want to start solving problems. So that's literally me, and it hasn't been even a year. Yeah, I don't know. It's kind of... Maybe the grass is always greener on the other end. Like, I don't know. Maybe that's kind of a situation. But it's just like, I don't want to be a programmer. Like, I still love computers. Believe it or not, like I still love computers. I love to work with computers and stuff like that. But man, I don't want to be a software engineer. Like just like something else, a system administrator or whatever. It's just. And I know Linux like well enough, right? So maybe I can be a system administrator. Network system administrators who I've even seen always behave like they're magicians and I always believe them. Bro, like look at Last Miles. Do you guys know who is Last Miles? I'm pretty sure he's streaming right now. Let's actually take a look at him. Last Miles. So, well, I mean, yeah, well, he's not streaming right now, but if you guys don't know who Last Miles is, I really recommend to check him out. He's literally a freaking wizard. So check him out. Right, a Unix wizard, the Gandalf himself, exactly, the Gandalf himself. But I don't know, like, can you consider him a system administrator? He's also a pretty good C programmer, right? So, I don't know, like, I think you can call people like that hacker, right? So we have a name for this kind of people, hacker. So he's a great Unix hacker. So anyways. So let's actually, we need to be able to build our project. And I just realized that this particular specific project doesn't even have any tests. For how useful this library is, I think it's a crime to not have any sort of tests, right? Just even smoke tests where you just compile the thing and just make sure that it compiles. It's kind of weird that, like, look at that. Look at that. It accumulated 351 stars. It is a useful project. And I know other people except me using this project, right? So like, I don't know why I neglected it so much. Yeah, I think I should start actually put more effort into like maintaining things, like adding tests and CI. Right. So let me maybe add knob in here, right? So because we need to be able to build this entire thing. So knob is basically a library that I use for writing build recipes, and we're gonna have knob C, right? So and this is where we're gonna write our knob recipe, knob.h. knob implementation, right? So because it's also STB style, and there's another thing I would like to have. I would like to maybe strip some prefixes, right? So because it's a little bit noisy, all right. So you have knob prefixes in here, and it's a little bit annoying to like write them every time. So I have an option to actually strip them off if you need to. Okay, so here I'm gonna do something like this. So we need to accept arguments. It's quite important. They are important for a knob go rebuild yourself technology, argc, argv, because it's using these arguments to grab the name of the executable and compare its creation date with the date of the source code. So then it can decide whether the thing has to be rebuilt or not. So in here, let's maybe create a folder. So may dir if not exist. So we need this kind of thing. So let's create a build folder. Build folder. And I usually like to call my build folder something like build with a slash, right? Slash at the end here is super important because in C, it allows you to do some cool shit like this, right? So essentially it concatenates this thing automatically. Because this entire thing is literal. If you put two literals together like that in C, it is actually considered a single literal like this, right? So if you didn't know that, so apparently it's kind of like a very little known fact, but yeah, so you can actually write literals like that consequently, and they are considered like a single literal, which enables you to sort of like concatenate paths in very convenient fashion. So anyway, right, so we create a build folder, right? So if it failed, we just return right away. We don't even have to log anything because make dir if not exist will automatically log if there's any errors doing so. So after that, I suppose I want to just like create something. So I need to create command, right? It's basically a dynamic array of the components of the command. So that's what it is. We're going to append some stuff in here. So we're going to append in there. CC, let's enable some flags. Right, so it's going to be WAll, W extra, then GDB. Every time I write in flags for my command line arguments, I feel like I'm making an order in McDonald's, to be fair. CC, WAll, W extra, GDB, pedantic, number 9, number... I'm so fucking sorry. Anyway, so yeah, so in here we have to do something like Mac compiler flags, exactly. So and in here we're gonna do a build folder expr, and then we're gonna do expr.c. So that's about it. So it basically appends all of these arguments into this dynamic array. And then there is a special command to run this dynamic array very conveniently. So cmd run, yeah, so I think it's a run sync and reset. Doesn't even have to be redirected. And reset. There we go. So you have to give it a pointer to the cmd, and then it will return whether it failed or not, and you can do something like this. So that's basically how you can do that. All right, so the only thing you need to do is just bootstrap knob.c, and then just run it once, and it will try to compile the program. Look at that. So it tried to compile this program, but it kind of failed because we don't use arguments in here. So maybe I'm going to actually put void in here so to make it compilable. Okay, so src is unused. I can say that I'm not going to be using it right now. And there we go. So and what it did, and now we have a build and expr in here. So in here we can even maybe print something like src equal to s. So here is src, and now I can rebuild it one more time and then build expr. There we go. So we have a very simple build system. No makefiles is required. No makefiles is required. You just use C to build C. So that's how it works. But maybe I would like to put expr into a separate folder, maybe something like examples. examples. This is not how we create folder, dummy. Examples. There we go. So I'm going to put it in here like this. Okay. And then after that, as you can see, I won't be able to build it anymore because it can't find the file. So let's actually create maybe some sort of a variable in here, example folder, examples. So maybe it makes sense for me to kind of put a new line in here. Let me think how I can go about that. So this is going to be that. Then this is the new line, right? And in here, I'm going to say examples folder. There we go. Then I can just run like this. And here's an interesting thing. Like, notice how I didn't even have to rebuild my build recipe. This is because it rebuilt itself automatically. Right. So as you can see, it even told you how exactly it rebuilt itself. First, it renamed the old executable, and then it compiled it again and run it again. So it detected that I modified it, and it will now basically constantly rebuild itself. Right. So people think that building, C with C is kind of tedious because you should constantly rebuild your build system so you can build your project. No. With this library, you can just like build it once, bootstrap it once, and then this entire system takes care of itself automatically. You don't have to think about it anymore. Right. So it's sort of like a self-contained build system. Okay, so it can't find arena.h because the expression is located within examples folder. So one of the things we probably want to do in here, we're going to say, okay, so search include in the same folder, in the current folder, and I can rebuild it. And as you can see, it actually builds now. So why would I need knob old? So knob old, it's sort of like remnants of the older versions of knob, where if it fails, you kind of lose your executable and have to rebootstrap it again. So just as sort of like a safety measure, I always preserve the previous version of the knob so you can recover it if something goes wrong during rebuilding yourself. So it's sort of like a safety mechanism. But what's interesting is that the current implementation of knob go rebuild yourself is so robust and stable that I never had to do that. I don't remember a single time I had to actually recover knob from the old one, to the point that I'm thinking maybe I should just automatically remove it. And it's not even that hard, right? So after you run it, you can just like very easily remove it. So yeah, I'm thinking about that. Like I was experimenting with some sort of a feature flag that you can enable and it will automatically delete it. Right. So, but it doesn't really create any problems by itself. So it's just there. In any case, this library is open, and you are supposed to copy paste it in your project, and you can modify it however you want, right? So the whole point of this file is that you copy it to your project and you adapt it to yourself. You can add functions, you can modify some functions, and so on and so forth. Right. So anyways, we got some le subs. I need to acknowledge them. Thank you so much, .chris1111 for 10 months subscription. Thank you. All right, so what do we have in here? So we build this entire thing, and now we are looking at examples expert.c. Okay, cool. So we need to allocate arena somewhere in a static memory in here. So this is going to be maybe like expert arena. Right, so I'm gonna just call it expert, and I'm gonna zero initialize it. The cool thing about this arena is that you don't have to initialize it. You just allocate a structure of arena and zero initialize it, and it's already a valid arena by itself. It's a valid empty arena, so you can start allocating memory into that arena right away. We can even try to do that. So we can do something like arena. Oh, there is a cool thing. This arena library comes with all sorts of helpers for you to allocate memory within arena. So obviously it has things like alloc, right? So just allocate some memory. Realloc, you can reallocate some memory. If you have dynamic arrays that grow over time, you can reallocate them within arena. Arena by itself doesn't have a free chunk of memory operation, so that means you kind of lose a little bit of memory. So that previously allocated memory is still going to stay there, but it's going to be deallocated on the next reset. Right, so it also has strdup, so you can duplicate string and basically move it into your arena if you want to. You can do memdup if you want to, and most importantly, you can do sprintf. You can basically construct new strings. They're going to be stored within arena with a convenient printf syntax. I'm not even joking. You can do that if you want to, right? So it's part of this entire thing. I think relatively recently I even added, mechanism for doing dynamic arrays within Arena, right? Remember my famous clip on Twitter? Like everybody reposts that on Twitter for DI append macro. Arena has its own DI append macro that appends allocating memory with the Arena, so you can append with the Arena. Right, so it actually like implements quite a few very useful operations for you to work with the Arena. What happens if the arena is too small, even empty, to contain a whole object? So let's actually take a look. So essentially it allocates the region of a certain size by default. That's the default capacity. So, and by default it's 8 kilobytes. If you try to allocate something bigger than 8 kilobytes, it's basically going to allocate a new region of that size. This is why regions actually store their capacity, because it can vary. Right. So if you allocate very big objects within the arena, they're going to kind of stretch its regions. But then when you reset the arena, that stretched region is still going to stay there. So you basically have a little bit of a bigger region if you want to. So that's basically how it works. Right. So you have to keep that in mind if your application is very sensitive to the performance of the memory allocation. It varies the capacity again. So by default, like you can always, I think, you can't change this thing. Right, so one of the things that would be nice to have is if you don't have this specific thing defined, we define 8 kilobytes for you automatically. So essentially that will allow you, for example, to redefine this default capacity. Right, if you know that you're allocating like a very big objects in here, you can just like, say allocate 8 megabytes instead of 8 kilobytes. Right, so very big objects. So, but by default, it's still gonna stretch. So it would be nice to maybe also have like a arena prefix for this entire thing. I'm gonna do that later. I think I'm gonna actually do this entire thing later. So right now, what I want to focus on, just like doing things. So we can maybe allocate some stuff. Right, so I want to print arena as printf hello. Right, so we're gonna put s and maybe d. Right, so hello world 69. So maybe also gonna put new line in here. Maybe since we already have printf, maybe it makes sense to just like do puts. So yeah, so what I want to do in here is just like I want to print this entire thing and see in the debugger how it changes the state of the arena. I think it's kind of interesting. Right, so I'm gonna do knob. I didn't compile them because I'm supposed to actually provide the arena within which I'm allocating all that stuff. There we go. Okay, so we can try to run the expression afterwards. Right, so it's going to be expr. Yeah, there we go. As you can see, it printed that. Does put new line in there? Really? Wait a freaking second. Is that true? Trailing new line. Why? So if I remember correctly, yeah, and fputs writes that thing without a new line. Okay, classic. So what if I do fputs actually? Here's the interesting thing. So fputs, but then at the end I have to actually put like where exactly I want to bring std out. Right, so in here I can do, I suppose, knob and automatically run the whole thing. Yeah, so that seems to be working. That seems to be working. Okay, so oh man, I really need my mouse right now because I'm going to be doing debugging and shit. All right, so let's just do gf2 electric boogaloo. Yeah, I didn't mean to do it like that. Okay, so I'm gonna break at main and I'm gonna I'm losing my voice, by the way, what the fuck. So I wonder if I can actually extend. Oh, look at that, I can. What the fuck? And we can take a look at the expression. What the fuck is this? GF2 is broken. The fuck? Honestly, I think I recently updated GDB. And I think it literally, yeah. I think GF2 might not be compatible with the latest version of GDB. Maybe that's the case. Okay, so let's go ahead and grab the newest version of GF2. So maybe it's actually fixed. Right, it's actually called GF. Maybe it's fixed. So the latest change was 3 weeks ago, but I mean, I haven't updated my system for quite some time, and I remember it updated GDB. Maybe it was already kind of fixed. So they are referring to some... Okay, oh, there you go. It is already fixed. It is already fixed. The beauty of open source. The beauty of open source, right? So you encountered an error, somebody submitted a pull request, and we already fixed it. Okay, so let's actually go ahead and just like fetch the version of GF. I don't have it anywhere in here. Do I have? Oh, there we go. So here it is. Look at that. Okay, so we have untracked files and GF2 and so on and so forth. Let me maybe visualize this thing. So I haven't updated my GF actually for quite some time already. So origin master, there we go. So not that many changes. It's not very actively developed these days. So let's do build.sh. Okay, so it is building. It is thinking at least. And okay, so and it created GF2. So that's pretty cool. That was pretty quick. So, and as far as I know, it's like literally like a single translation unit. It also tries to check you. This is kind of cool. It tries to check your version of GDB, and then depending on the version, may do different things. But anyway, so I need to install it system-wide because in here, if I do GF2, as you can see, it's installed like system-wide. I need root in here for that. So I probably have to go into streamer. Third-party GF2, right? It's just GF. So here it is. I'm gonna copy GF2 to user local bin like this. And I think I do have a bunch of custom executables in here. Yeah, quite a few executables. I'm not gonna close root because it's a very useful console. Anyways, so now we should be able to go back to the expression and try to open it in a debugger. There we go. So, all right. So this is the latest version. Using touchpad is unbearable, honestly, but I mean, it is what it is. And so in here, I can take a look at my expression arena. Look at that, it already fixed. And as you can see, it contains 2 pointers, and these 2 pointers, they are 0. Okay, so let's actually try to do next. And as you can see, it allocated first region. And what do we have within that region? Something is really fucky-wacky within that region. I didn't expect that. Because did we just find a bug? Because I would expect it to allocate this entire thing within that region, but it fucking didn't. So count is 3, so it can't be 3 bytes. I don't believe that. So apparently we just found a bug. So what's the data? Right, data is supposed to be a pointer. Okay, we can do something interesting. So expression begin data, and let's interpret that data as pointer to the character. Right, so let's interpret that. And here we actually have everything in here. I think I know what is going on. Yeah, I think I know what is going on. The count is not in bytes. The count is not in bytes. The count is in machine words. That's a thing I forgot. So the count is in machine words, and that's a huge confusion in here. Yeah, because yeah, so this is, as you can see, it's not like bytes, it's uint pointers, it's machine words. And we do that to keep the allocated data aligned by a machine word. Not really sure if it's that, well, I mean, it's kind of important, right? Especially if you, imagine you allocated like 3 bytes of a string, and then you try to allocate structure, and it's going to be allocated. Right, so basically you allocated 3 bytes, 1, 2, 3, and then you allocate some sort of a structure that requires a very specific alignment because it has padding and stuff like that. So it's not going to be aligned properly in the memory if you just try to do it like that. It's kind of dangerous. So because of that, we kind of like, you know, pad this entire thing to the size of the word, and only then, so we have a little bit of like holes in here every time we allocate things, right? So if it doesn't perfectly like align, we just pad things, so then we can allocate structures and so on and so forth. Isn't it smart? Isn't it smart? I think it's perfectly smart. So yeah, so there's no mistake in here, but I'm still glad that I looked into that in a debugger, and we figured that out, that debugger was broken, so I need to update the debugger. So capacity, haha, very funny, very funny, very funny. So that's pretty cool. It's pretty cool. Show CMD bun. Is the bot dead? Oh fuck, the bot is dead. How come? I don't know why, but the bot is apparently dead. Who killed the bot, chat? Who killed the bot? I didn't expect that. What the fuck? How come? Yeah, exactly. Just a second. Just a tiny little second. I need to double check. I probably don't even have to do it like that. So, okay. So I'm gonna try to restart the bot. I just restarted the bot. So is it working? Is it working? No. That is bizarre. Huh. It is not responding or anything like that. Okay, just a second. I'm gonna kill the bot then, just in case, because who knows. And I'm gonna investigate all of that stuff later. It seems to be connected, so maybe it's something on the Twitch side. It could be something. Oh, I can't even kill it, so that means... Maybe, I think the token has expired, so that's one of the things that happens quite frequently. Gatekeeper. 264, 820. Yeah. Yeah, I think this is a very classical situation of, you know, the token being expired. Buy more Twitch, yeah, exactly. So anyways, whatever. We don't have a bot anymore, unfortunately, but it is what it is. So I'm gonna fix it after the stream. So everything seems to be working, everything seems to be working, so the arena and stuff like that. So let's just try to maybe parse it. Right, so we need to have some nodes and stuff, right? So we're gonna have a node, and the nodes are going to have different kinds, right? So because you're gonna have operations and numbers like this. So we do a little bit of the computer science. So we're gonna have nk number, right, number, nk plus, and nk multiply. It's called mult, so they are sort of aligned with 4 characters. And let's call it num. Num. So they all aligned with 4 characters. I think it looks nice. I really like when it's aligned like that. But anyway, so here we're gonna have different things. I suppose if it is a number, we're gonna have like an integer. So here is a number, and if it's a plus or multiplication, it has to be like a binop, right? So Linkin Park, exactly. Just it's a Linkin Park reference. So let's have something like a node binop, and in here we're gonna have node left-hand side and right-hand side. So, but we are referring to node that is not defined yet. So that means we have to forward declare it. Thank you very much, C. Very cool. Imagine forward declaring types in 2025 still. SMH my age. SMH my age. Right, so this is a struct node, a node. So I just forward declare the type. And since I already typed def node, I don't have to type def it second time. Right, so, and there we go. And yeah, so here's that. Or you can now do node binop. Maybe we can even make it a union like that, so it doesn't waste too much memory. Right, but I mean, it's just like, it doesn't matter. But it's kind of nice to have it as a union. Okay, so I try to rebuild the whole thing, right? So I try to rebuild the whole thing, and it seems to be working. So it would be kind of nice to have some sort of an operation that automatically allocates you a node. All right, so for example, I want to create a like node number, and I just want to provide the number, right? And I want it to automatically allocate a new node within the expression arena. And since I'm going to be storing nodes there primarily, I think I'm going to just call it nodes. Right, so this is where we store the nodes when we allocate them. So in here, what I do, I just do arena alloc size of node, just allocated that. And here is my node. The very important thing in here is that it has to have kind nk number, and then the number itself is going to be equal to the number. And we just return the number. There we go. Maybe I'm going to call it number. Right. So here we're going to have plus, which is going to accept both LHS and RHS. So this is plus LHS, RHS, oh, LHS. Then duplicate that, RHS. Boom, copy paste that. Who needs templates? Malt and malt. There we go. So now I can use these functions to actually create new nodes, and they're automatically allocated within that arena, and I can deallocate them all at once if I want to. Right, so it would be kind of nice to maybe be able to print all of these things somehow. Right, so let's actually create something like node print. You're gonna accept the node. Maybe I'm gonna call it even root, because we're starting from the root, and then we're gonna switch case and all of that stuff. So this is gonna be root kind. So, and what kinds of kinds, how many kinds we have, what sorts of kinds we have. Right, so this is going to be something like that. So this is the case. This is the case. So it's going to be that. So when it's a number, it's actually pretty straightforward. We just do print that number, right? So it's root number, nothing special. And then we just like maybe break out of this entire thing. So if it's a plus, what we have to do, we have to first print left-hand side. Let's actually print it like in a sort of like a functional syntax, right? So this is going to be plus this thing, then semicolon, then node print left-hand side, then right-hand side. Between them, I think it makes sense to put a comma, and then at the end, closing parent. And then we're going to break out of this entire stuff. Multiplication is going to be the same. It's just like instead of plus, it's going to be called mult. And since it's C, you may have a little bit of a memory corruption, and root might be pointing to some garbage. So that means kind may not necessarily be one of these things. So you need to have a default case just in case that basically aborts. Right, so we can do something like fprintf. Usually I say unreachable, right, but unreachable comes from knob, and I don't want this example to depend too much on knob. But yeah, so I'm going to do something like fprintf stderr unreachable, right, and then I'm going to abort after that. So something like this. So this is basically the printer for all of these things. And now we can quite easily do this kind of stuff. So it's going to be node multiplication, right? So let's actually try to create this sort of example. We're multiplying node number 2 and node number 17, right? And then we add node plus node number 35, right? And that gives us the expression, right? Some sort of expression, and it allocates all of these objects within that arena. That, right? So then we can put all of that stuff in here. And I suppose now we can just print node print, and I'm just printing this entire thing. And then at the end, I probably want to put a new line. So I got some subs. Thank you so much, Frantizik 1917 for transcription model message. Thanks for the inspo. It turns out cognitive science grad school is just Python development. So I get to stun everyone with knowing what allocation means. Here is an interesting thing, is that I think you can, write allocators even in such languages like Python. Because in Python, you work a lot with lists and arrays, right? And quite often you may have like a pool of some sort of like objects or things, and you can manage their status or their state over time. And what is it if not allocation, of like a form of allocation? So yeah, Python has memory views. No, I'm not really talking about that. I'm talking about, it's just like you're managing some, if you're managing some objects under a state, you're kind of doing memory allocation. It's just like you don't call it memory allocation. Anyways, so we got that. So let's try to rebuild the whole thing, and I have to be in a different folder, right? It doesn't compile, right? What is going on in here? So size of, yeah, first, if I want to allocate something, I have to provide the pointer to the arena where I'm allocating all of that. That makes sense. That makes a lot of sense. I do agree with that. So, and it doesn't have LHS and RHS because LHS and RHS come from bin op, right? So they're part of bin op. Bin op. Let's go. Let's just go to the compilation errors and fix all of the necessary compilation errors. Port flashbacks. What kind of port flashbacks are you experiencing right now? I'm not quite sure. Right, so did we do some sort of like a arena allocation in ports? Well, we did have like temporary allocator, but I wouldn't say it was specifically like an arena allocator. It was a fixed memory region. It was kind of, or you mean binop, like in port we had binops. All right, memory management in Python. I see. All right, so let's go here. And I'm gonna try to execute build expression. There we go. So here's our expression, right? So this is our expression. We created a tree, and then we just printed this tree like that. So isn't it cool? I think it's pretty cool. So, and I don't have to think about allocating each individual objects now. What I can do, I can just do arena free nodes, and it will automatically free the entirety of these things for me. Right. So if I just try to build, I'm always in the wrong place. I'm always in the wrong place. Like that, everything's fine. And then I can do val grind. Okay. No leaks are possible. All heap blocks were freed. No links are possible, even though we allocated 1, 2, 3, 4, 5 separate objects. We allocated 5 separate objects, and then we called free only once, and it deallocated all the objects at once. And valgrind actually confirms there's no leaks in this program. So that's basically what arena allocators are. You can actually do something like reset, and it will leak memory, right? So it's kind of weird. This is because I didn't recompile my whole thing. Yeah, there we go. So we just reset, and it leaked some memory. And this is because when you reset, it basically marks the arena as empty. So when you allocate more objects, it actually reuses the memory that it already allocated to allocate the objects in. So you can do stuff like that. And to be fair, like this kind of memory doesn't make any sense to clean at the end of the application. Operating system is going to do that for you anyway. So yeah, anyway, what we need to do, we need to now maybe write some code that justifies this kind of mechanism, right? So we need to write some code that justifies having this system that allocates trees and stuff like that. Let's try to maybe parse this specific expression. Why would you not use arenas? Oh, you guys talking about something in the chat. Okay, cool. We can do something like parse expression, and it is going to just accept const char src, and it's going to return nodes, right? It is going to return nodes. So again, we're not tokenizing anything to just simplify the implementation. So what we have to do in here, we have to take a look at the first character in here. So what's going to be the first character? So it could be either, you know, open parent. So this is going to be open parent. Then it could be something, it could be a digit, or it could be a 0. Anything else is kind of unexpected. Because it's kind of like a limited thing that you can have in here, maybe it makes sense to not use switch. what we can do in here is just like src equal to this stuff, right? So in this thing is not implemented yet, right? So to do else if src is digit, so this is one of the digits, so also not implemented. Otherwise, I suppose src is basically 0, so there's nothing in there. But in that case, I think it's just like unreachable, right? Or maybe some sort of an error in here. And maybe we can do, maybe we can even do something like this. So we either expect open parent or a digit. If it's something else, we kind of, but we don't do anything in here. Okay, so if we encounter open parent, what we have to do, I suppose, we have to try to parse expression again, right? So it kind of forwards the expression further because it's a compound expression. So in that case, I feel like we just do a return parse expression src plus 1. We're skipping that specific thing. Okay, so if it is a digit, right? If it is a digit, we you know, try to parse it as a number, right? So that's what we're doing in here. So how to parse it as a number? So A to I forgot, how do you do, I think it was str to D. Was it str to D? Maybe it was str to N. So what was the name? Str to L. Yeah, this one, str to L. So let's actually grab this entire thing and put it in here. So we provide the pointer to the thing that we're trying to parse. So then it wants a pointer to the pointer where it's going to store where it stopped parsing this entire thing. So let's actually allocate something like end ptr and provide this entire thing in here, right? End ptr. And we are going to supply 10 as a base in here. So this is going to be n. So here's the thing. If it didn't manage to parse anything, so the end ptr is probably not going to be, is going to be equal to src, right? Because src didn't advance. Nothing is like advanced in here. So, but since we made sure that this specific first character is digit, that means it will advance at least something. So that means this is an assertion, right? So we're going to make sure that src is not equal to end pointer. Otherwise, there is probably a bug in str to L or in is digit, but both of these functions are library functions. So, but we want to actually assert that just in case. So after that, since we parsed this number, we need to kind of advance this src. But we have to advance it so it is visible to whoever calls this function, right? We need to somehow advance it so it's visible to whoever calls these functions, which means that we have to pass it as a pointer because we're going to be modifying, because it's sort of like a lexer. You know what I'm talking about? All right, it's sort of like a lexer, which makes it not particularly convenient to work with, right? Which makes it not particularly convenient to work with. It's just like now it's like a 2 levels of indirection, and I have to think about it. SV time. Maybe it is an SV time, right? But bringing an entire library for an example, I think, is too much. I think bringing an entire library for an example is already too much. Because it's not an example of SV, it's an example of arenas, so I don't want to overcomplicate it too much. So because of that, okay, so this is going to be this. And yeah, so that means what I have to do is, man, this sucks. So I don't want to be doing it like that. So what I'm thinking is that we need to have something like a struct, like one layer of struct would have been actually perfect to sort of like remove mental burden of multiple pointers, right? I think it's kind of important here. So Lexa, sort of like Alexa, but it's such a stupid name for this entire thing, so I'm not really sure. Maybe it's going to be source, right? So it's going to be source. And I can take it as that. So, and in src, let's call data, right? Maybe cursor. Yeah, it's called cursor. I think it's a good one. So src cursor is like this. Okay, so that's a little bit better, right? So we kind of moved the second interaction into this arrow, so now it is a little bit easier to work with, right? So this is that, and because of that, I just do cursor plot. Okay, look at that. This is actually much easier to work with. So I advance this entire thing, then I parse another expression, src like this, and then I suppose I have to say that I expect closing thing in here, right? So, and if it's not equal to that, I issue an error. I issue some sort of an error. So, but to be able to issue an error, I need to point where exactly that happens. So maybe I need to also keep track of where we have a beginning, right? So we have a beginning of the source code and the cursor and so on and so forth. So then I can tell exactly where this entire thing happened. So fprintf std error error. So maybe we can put something like, I don't know, d. So expected this, something like this, and then how we can compute the current cursor. We can do src cursor minus src begin, and that's what we have in here. We'll also probably have to put a new line in here, and then we're going to return null, indicating that this entire scheisse has failed. This entire scheisse has failed. So yeah, today doesn't work because the bot is dead. I'm sorry. Thank you so much, Twitch. Thank you so much. All right, so maybe I want to make a small break, right? So because I'm already streaming for 1 hour, by the way, 1 hour. I want to make a small break, make a cup of tea, and after the break, we're gonna continue working on this example. As soon as we have some example that allocates some memory, we have at least something to work with, something to port to WebAssembly, right? So right now in this project, I don't even have anything that I could work with, so that's why I implemented this entire thing. Shouldn't be that difficult. So anyways, and by the way, Twitch for some reason keep reconnecting my chat arena, so I suspect that there's maybe some technical problems with Twitch today. So that's why the bot doesn't work. Thank you so much, Twitch engineers. Very cool. Anyway, let's make a break. I'm back, motherfuckers! Zozin is back! So let's try to maybe parse this entire thing. I don't fucking know. Right, so if we encounter an error, so source is basically like a simple Lexa, which is kind of cool, but I need to be able to construct, you know, a source out of just systar. I'm gonna sneeze, by the way, just a second. Just a second, chat. Any minute now. Debated, haha. So what I need to do in here, I need to construct like str to src. So in here we supply the source, and here we accept the str. So, and what I'm going to return, I'm going to return clitoral. So, and both of these things like are going to be as systar, right? So here's the beginning and here's the cursor. So the only thing I need to do, I just need to duplicate this systar in here. So that way I can do something like source, and then I can do systar to source like this. And there we go, I got source. Pretty cool. So after that, I need to parse an expression. Right, I do parse, I take a pointer to src, and I expect this entire thing give me, you know, an expression, which is like a node, which I then can print like so. So this is basically the example at the higher level. This is basically an example at the high level, but we still need to implement parse expression. So this entire thing is kind of implemented when we encounter the digit, right? When we encounter the digit, what I have to do, I have to do the yeah. So let's go to the compilation errors, because obviously this entire thing is not going to compile, and the easiest way to fix it is to just go to the compilation errors, right? So let's go. So D. So what you don't like in here? This one is interesting. So this one is more like a long D, right? So when you take a difference between the pointers, you get a value that is actually long integer, not just integer. So, and this is what the compiler complaining about. So in here, we probably have to do something like cursor, like this. Okay. So what's the next error? You don't have isDigit because isDigit is defined in C types, if I'm not mistaken. If I remember correctly, I think it's just C type. Yeah, it is. So here's the cursor. We're starting from the cursor and we're just trying to parse a number. So after everything is correct, we just set the cursor to end pointer because this is where str2l will store the pointer where it stopped processing the numbers. So that's what happened in here. All right, and after that, I suppose the easiest thing to do is to return the number, right? So we have node number and we just allocate the number n. So we just parsed a digit. So here I just realized that I never return anything and I think I should. Right, so I'm going to take an expression, I'm going to save it, then here I expect specifically closing parent, and then I return the parsed expression. So that's how it works. And if I encounter something else, I think I also want to print that I encountered something that I didn't expect. All right, so if I do something like this, std error, right. So let's do something like error. So this one is LD, error, unexpected character, and it actually depends whether this character is 0 or not. So we can maybe separate this entire thing. So we can do something like if this cursor is actually 0, we can say unexpected end of source. Look at that. Look at that. So src cursor minus src begin. And then we can return null, indicating that you did a fucky wacky, oopsie doopsie, ooh. And then if we have something like this, we can now print an expected character. And it's going to be something like C. And that character is going to be src cursor like this. And then we're going to return a null, indicating the fucky wacky situation. So basically like this, but this thing does not parse binops. That's a problem, in my opinion. That's a problem. So let's actually try to test this entire thing. So it compiled. No, it doesn't compile. It doesn't compile. So let's actually see what we have in here. So comparison distinct pointers. Yeah, this is because it has to be the cursor. There we go. So it compiles, and if I try to run this entire thing, it is going to say, yeah. So it didn't understand. It didn't understand. It would be kind of cool if it actually printed, you know, the modern compiler style stuff, right? So here is the expression and where you did a fucky wacky. You know what I'm talking about? So it's just like prints a chunk of code and then, bruh, fucky wacky. Please don't clip that out of the context. So you know what I'm talking about. So essentially how we can do that, we can first of all print the whole expression, and the whole expression is actually at the beginning, right? So this is the begin, right? So this is how we can do that. Knob like this, str, yeah, there we go. So we forgot a new line. Let's fucking go, yeah, something like that. Then we can basically pad with the spaces and stuff like that. Does anybody remember how to pad shit with printf? So essentially I have a number. Yeah. So something like that. I wish I could quickly just show. Yeah, so something like this. Yeah, so just like fucky wacky. This is fucky wacky. This is what I want to implement. What we can do? Can I do printf std error, right? I have something like this, but then I want to print like a s, and I can actually do something like this. So essentially I supply the width of the element in here, and the width of the element has to be this thing. The width has to be this thing, and what we're printing in here is this thing, and obviously it also has to have a new line. So, and then we can also print like expected this stuff. We can maybe save this entire stuff to I don't know, n. This is going to be n. We can save it in here. So and then we can even factor it out to a separate function that does diagnostic reporting and stuff like that. So we forgot the semicolon. That's totally fine. What else do we have in here? So it's not LD. This is just D. And yeah. So expected that, right? Expected that, but got something else, right? Maybe this is what we have to say in here actually, but it's kind of yeah, correct. So 0, 1, 2. Okay, so this is not precisely what I expected in here. We need to add 1 to this entire thing. So let's quickly do that. Expression.c. Maybe let's put that stuff in here, and let's put this thing in here. I think that is going to work. Yeah, there we go. So I think it actually now points at the correct thing. I think it points at the correct thing. So here we can say expected that, but got something else. Right. So, and since we wrap the characters, in quotes, we have to do it like that. So you're suggesting to do in the chat something like this, but it actually just aligns it in a different to a different side, right? So it basically snaps it to the left. We need to snap it to the right, and it already does exactly what we need. Why is Wasm making a parser? Because he wants to, and because he can. How about that? Can you just like wake up one day and say to yourself, I want to make a parser? No, go color this button. No, make the corners round. No, you can't make. Wasm can do that. Wasm can actually do that. I can wake up one day and say, I'm gonna make a fucking parser. Fuck your colored buttons. Fuck your rounded corners. I'm making a fucking parser. Center the diff wagey. Exactly. So that's why I'm making a parser. Because I fucking can. So, all right, let's continue. So this is that, and but good, this kind of thing. But it may not work if we reach the end. But I just want to see what exactly we've got in there. Boom. Yeah. So look at this beautiful freaking diagnostics. Look at this. That is so fucking cool. I really like that. So somebody asked in the chat, can you explain how this entire thing works? So essentially, it actually, you know, allows you to set the width of a specific element in here. So that's how it works. To explain how it works, I think we need to create a separate file. So let's create a separate file. It's an interesting question, right? So not everybody knows that. And funnily enough, as far as I know, the format system of, I think, Rust kind of inherited similar idiom of doing things, but the syntax is slightly different, right? So the syntax is slightly different. So we can now say something like we can copy paste this entire stuff in here and just compile foo, but in our case foo is actually not located in the examples, it's located in here. Right, and now if I try to build the whole thing, or it builds both of these things, right? So it builds both of these things, I can do build foo. So I just printed 69. So in printf, there is such notion as width of the element that you're printing. So if I put width 2, right, nothing will really change. It's like nothing changed at all. This is because the size of this number is 2. But what if I put 3 in here? So it makes sure that the size of this entire element is exactly what you set. So, and to achieve that, it pads it usually with spaces. It pads it with spaces. So you can actually put 10 in here, and it will pad it with 8 spaces, right? So as you can see here, down there, if you look at like down here, it says 8 characters. So it padded with 8 spaces. So there's different modifiers in here. For example, you can put minus in here, if I'm not mistaken. And I think you put it in here, -10. and it will pad it to the right. So essentially you can't see it because there's nothing more printed in here. But if you wrap it around with these bars, you can actually see that. So with this minus, you can control the alignment. Align left, align right. Can your CSS do that? I don't fucking think so. You can just align shit left and right. So what's interesting is that you can not only like pad with spaces, you can pad with zeros. Can your JavaScript do that? Your JavaScript needs a freaking third-party dependency just to achieve just a fraction of this power. Actually, not true. They recently added to the standard library, but whatever. So yeah, so this is literally left pad. I wonder what's going to happen if you put minus in here, right? So yeah. Zero flag is ignored with my. Okay, so there's even like a warning in here that minus doesn't make any sense when you put zero in here. But anyway, so in our case we have something like that. But there is a kind of a problem in here. You must know 10 at compile time to be able to pad it. What if you don't know it at compile time? What if you receive it through some sort of a variable that you actually parse through some config or something like that? How do you achieve that? Like I have this padding in a variable. How do I use it? Well, you put star in here and you say, take that size of the padding from this variable. And there you go. Now I can control this thing from the variable. My monitor, yeah. That's what it is. And this kind of format works not only with numbers, but also with a string, right? So I can have something like hello in here. What that means is that I can now use this mechanism as a way of padding the cursor for my diagnostic. There you go. So does it make sense? Isn't that cool? I think it's pretty cool. So yeah, and as far as I know, Rust formatting system has similar concepts. It has the concept of padding with spaces, padding with zeros, then aligning the padding to left or right, and also having the dynamic padding that is through the variables. But the syntax is slightly different, but it's kind of similar to this one, right? So printf is like its own language, right? So that's why everybody hates it, right? Because you have to learn this kind of shit. Right, so now you know it's pretty cool. Because if you don't know this kind of thing, you probably have to write it with like for loops and stuff like that. Printf is so powerful to even call it CVE, so that, yeah. So it's kind of, its implementation is rather complex. But anyways, so let me remove that, and I'm also gonna remove this kind of stuff from the compilation. Right, so we're not building this stuff anymore. There we go. Cool. Maybe I'm gonna remove build so I can recreate it one more time. Cool. So in examples, expression.c, and we have this kind of stuff. So the only thing that kind of worries me is that if cursor is null, it's going to print null in here, which is kind of stupid. Right, so, but I mean, okay, so I'm gonna just leave it as it is. So what does it says when you try to actually, parse and so on and so forth? It says that it doesn't understand this freaking star, right? Which is understandable. So it doesn't know how to parse binops. So what this entire thing does in reality, like parse expert, it parses like a primary expression, just like a primary expression. So let's actually do primary. So parse primary. We need to have a separate thing on top of parse primary which parses binops. Right, let's do that. Parse binop. It is going to accept the source src, and the first thing it has to do, it has to parse LHS, right? So this is how we do that. Parse LHS. Parse primary. Yeah, so I think we're gonna do a parse primary, And then, so src. After that, we need to take a look at the cursor. So if src cursor is not equal to 0, that means there is a right-hand side to the whole operation. If it is equal to 0, that means we reach the end. This is basically the end expression, so we don't have to do anything. We can just return LHS like this. But if it does have something, it has to be one of two things, either plus or star, right? Either plus or star. So let's actually take a look at that. So if src cursor, so first of all, I think we have to allocate like a new node in here. Right. Not even quite sure what's the easiest way to do that, because when you do node binop, you need to know its kind up front, right? Or node plus. You need to know its kind up front, which is rather annoying. I would rather maybe just allocate the node like this. Just simply allocate the node like this, and then depending on what kind of stuff I have in here, right? So maybe switch cursor. Let's take a look at this stuff. So if it is plus, I do node kind plus, right? Node kind plus, then I break the whole thing. Then multiplication, this is mult, and if it's something else, we need to print bruv. We expected something else. And by the way, I forgot to print the diagnostic, proper diagnostic here for all of these situations. All right. So for all of these situations, maybe, as I already said, this specific source code has to be its own separate function that operates on source. Right, so let's quickly do that. Source, how can I call it? Location, right? So we accept source, pointer to src, and what it does, it just does this kind of thing, like this, boom. And we kind of lost access to n because we copy pasted it inside of that function, so maybe fuck that n. So it's going to be just an error. So source, location, src. There you go. So we just print the location like that. So in here, another source location src. I'm going to copy paste it in here. Another source location src. In all of these cases, let's not print any of that stuff. So I probably should try to compile, because the compile will tell me all of these errors in here. But I kind of don't care. Who needs compiler? Who needs compiler? Okay. So, and in here now, we can do the usual thing that we already did. Source, location, src. And then we can print something like fprintf std error. We can say unexpected character. Unexpected character, and it's gonna be C. It's gonna be C. What's gonna be the character? It's src cursor. Let's fucking go, and we can just return null in here right away, indicating that we did a fucky wacky. Cool. So in here, what I can say that the left-hand side of the binop is gonna be whatever left-hand side we managed to parse in here. So I just do it like that, and then we're gonna do binop RHS. And we have to try to parse actually another binop, right? So it's going to be a recursive like thing, just trying to parse another binop. But it may fail, by the way. It may fail. So we have to be a little bit careful in here. So let's just save it like this. And if RHS is equal to null, we should not proceed doing anything. Right, we should not proceed doing anything. We should return null right away. And by the way, speaking of why arenas make this kind of stuff easier, you may have an error, a syntactical error, in the middle of allocating a bunch of small objects. And once you have an error, you have to not forget to allocate all of them, otherwise you're going to leak all of them. But since we're allocating them in arena, we don't care. That's the beauty of using arenas for parsing things, is that like as we parse, we're just like shitting out small objects and we don't give a shit. We don't give a shit. Have an error? Okay, unwind the stack and just deallocate all of that garbage simultaneously. Something that people prize garbage collectors for, right? This is literally an advantage of garbage collector, but achieved without garbage collector through arenas. So yeah. So what happens when arena runs out of memory? I mean, it runs out of memory as soon as the operating system runs out of memory. It expands, it adds more and more regions. Garbage collector, but you choose when. Yeah, almost like that. Right, so it's not like you call garbage collector manually. No. You also decide lifetimes also manually. Right, garbage collector, one of the responsibilities of garbage collector is to identifying which objects are unreachable and became garbage. Right, so basically identifying lifetimes. You manually identifying lifetimes, right, so you basically group a bunch of objects into the same lifetime and then manually decide when that lifetime ceased to exist. Right, that's basically how it works. So there is a second component to that. It's not like manual garbage collector. Right, so you also need to kind of mentally, semantically decide in which lifetime certain objects will live. So if it's null, we just return null. If it's not, we can do something like binop RHS, RHS, like this. And that new node, this is what we have to return in here. In fact, maybe we can just, yeah, so I think that's a little bit easier to do like that, right? So we just return node, right in here is going to be RHS. All right, so yeah, but maybe it would be okay for us to simply save that stuff in here, and then if it fails like that, return null. So it's a little, yeah, look at that, it's a little bit easier to read. And by the way, this thing can also fail. If it's null, we also should return null immediately. So we try to parse the left-hand side, failed, return. Didn't fail, okay. So if we reach the end, that's the only thing that is left in here. We can even, you know, unnest this entire thing even further. If it is equal to null, just do that, and there we go. We unnested this entire stuff. All right, so that's pretty cool, I think. Ah, what the fuck am I? Something really, so my indentation system shitted itself trying to, okay, understandable, maybe this is because of the breaks or something, but yeah, sometimes it just shits itself. Yeah, now it is working. Beautiful. Default is missing block. Yeah, it's fine, it's totally fine. All right, so that's basically it. We also already print location, so there you go. And what's funny is that when you want to parse an expression, you have to always call at the top level parse binop, which probably means that we want to have like a nice wrapper around it, right? So we're going to call it parse expression is going to accept source src, and at the top level is going to parse binop. Like so. Yeah, so we're parsing, yeah, and it actually fits in here. Let's try to rebuild the whole thing super quick and go to the compilation here. So parse expression. So that's interesting. Yeah, I think it does make sense to call parse expression in here, but we have to forward declare stuff in here. So we're forward declaring. Yeah, imagine forward declaring in 2022, 2025 actually. Still living mentally in 2022, goddamn. All right, so let's try to run this entire thing. Okay, cool, and it didn't advance at all. And in some cases, it didn't even fail properly. God damn. Okay, so we have that. I think one thing I forgot to do in here. If expression is equal to null, just return null instantly. Don't try to look into anything or whatever. So because that's kind of a recursive call in here. So will that fix actually? I think it might. Yeah, it fixes. So I feel like what happened in here, chat, is that we didn't advance the cursor after parsing these things. But we managed to parse this thing, but we didn't advance the cursor. So that's kind of important. src cursor, advance the cursor, and then try to parse things yet again. right, I think it probably makes sense to do something like this, right? So we instantly, we verified that LHS exists and stuff like that. Then we allocated a new node, right? Instantly assigned LHS, then checked what kind of node is that, advanced the whole thing, and parsed right-hand side. I think that may work. Okay, so unexpected character, which is kind of weird, right? Isn't it? I see. So here we expect this thing, but again, we don't advance it after expecting it. All right. And that didn't work either. So if it doesn't expect, So maybe we need to provide more information. Unexpected character, expected this or a number. This or a number. Okay, so it's not that. Unexpected. Unexpected character, expected plus or this. Yeah. So that's very interesting. So it means that parsing this primary expression didn't advance this thing, but I literally did advance it. What's up with that? Should be parse expr. Maybe it should be parse expr. So yeah, this could be actually parse expr. But then we have to do parse primary at some point. At some point we have to start doing parse primary. So I think, so expr. So at which point we do parse primary? I think this one has to be parse expr, and this one has to be parse primary. Yeah. Segmentation for the fuck? That's the last thing I expected in here. Okay, very interesting. All right, but no error. Exactly. So let's actually do GF2. Electric Boogaloo. Let's run the whole thing. And what? So I'm in the wrong place. Okay. Let's run it. And where did that? Oh, it's a Stack Overflow. I see. It's a freaking Stack Overflow. Something does not. Yeah. So as you can see, here is the stack. So it's a huge stack. It's not really stack fault. It's simply Stack Overflow. I'm not sure. Like, what the fuck? Why it didn't advance anything? It should be advancing shit, in my opinion. So who's not advancing stuff? Who's not advancing stuff? So we got that. Right, so we got this thing, and we did +1, so we skipped that thing. Then we parse another primary. Or parse another expression, so that means inside we can have binary and stuff like that. That's fine. If it failed, we do that. Then if it's not equal to this one, we just like return null, which is understandable, but then we always advance the cursor. All right, so that means there's no being stuck in here or anything. So in here we do this stuff, and then we advance the cursor with the new endpoint. So nothing is stuck in here for sure. Nothing is stuck. And these are just unexpected cursors. They all indicate an error. Okay. So LHS, I do that. That's understandable. So if it returns null, it's error. If we reach the end, we just return that left-hand side. Okay, so if it's not end, that means we have some node. All right, so we allocate the node, we save LHS in there, and we look at what cursor contains in there. Depending on its type, we just do some of these things. If it's unexpected character, we just say it's an expected character, but then we advance the cursor. So we can get some stuff. And then we parse the primary expression in here yet again. So parse expr calls parse binary, which calls parse exprs. Well, I mean, yeah, that's kind of the point. So all without changing state. All without changing state? What without changing state? Source cursor +1 is changing the state. is change the state. This is not helpful, chat. This is not helpful. Right, so at the beginning, what are you guys talking about? You're just saying words that don't make any sense. So need cursor after RHS. What are you guys even talking about? I don't fucking understand. Line on. Okay. Okay. All right, I think I need to do the debugger. Okay, so you're just saying random words, trying to trick me into thinking that you're saying something useful. In fact, you don't say anything useful. All right, so we're gonna break at main, and we're gonna just like look into this kind of stuff. Right. So what do we have? I probably and my mouse doesn't work. Just like I can't read your mind. Like you saying things out of the context, I have no idea what the fuck you're trying to tell me. Like it's not helpful. Like screaming out variable names, RHS, RHS. It's like what RHS? What the fuck are you saying? Right. So let's actually go inside of the parse expression. Right. So what I need in here, it's src. Right. Okay, so let's actually see how it advances the thing. All right, so I'm going to step into that. If I, yeah, okay. So it's instantly, let's try to run it again. Let's try to run it again. I'm going to step into that, step into that, step into that. So that makes sense. So that means that thing has to be primary. That thing has to be primary. Okay. And that thing has to be expression. All right. So that makes sense. So the debugger is helpful. Debugger is helpful. Chat is not. Now, let's try to do that one more time. And gf2 expression. So break main. Run the whole thing. So let me. So it's going to be src. I really apologize that I'm moving my mouse so slowly because again I'm using like a touchpad. All right, so I want to. So did some things. And then it didn't advance what I needed to advance, unfortunately. Right, so it kind of stopped at that. And I do not quite understand why. So then if we try to print, it printed not fully, right? So we didn't print this entire thing fully. Yeah, so it just means that we didn't consume this thing, which is not true. Which is not true. So that's kind of bizarre. So let me try to do that. I'm really tired of bringing this thing over and over again because you guys cannot see it. Like I don't know how to make it just bigger always. Like it would be kind of nice if I could save the layout in GF so I don't have to reshuffle it over and over again. Because it's kind of annoying. It's kind of annoying. All right. It is kind of annoying, not gonna lie, right? So because you can't see this thing, so now what I'm gonna try to do, I'm gonna try to run it. And let's actually step through multiple things. So this is gonna be that. So this is primary. Okay. Okay. All right, so I'm gonna step into that. So it's equal to that. We increase the cursor. Okay. So then we try to parse another expression. So I think I'm gonna step over this entire thing. Okay, that's understandable. So we get that stuff. Wait, what? Did it return null? Motherfucker just returned null somewhere. So that's why it didn't, so because it couldn't parse the, I see. This is fucking sus. I think I know what the fuck is going on. Yeah, I think I understand. So essentially, what we have to do is that if cursor not equal to plus and not equal to multiply, then we return. Okay, so you may encounter not only and, but for example, closing parent. So that's what may happen. That's what may happen. Damn, the debugger is so actually useful. Just stepping through this entire thing and see what's going on. Like I should use debuggers more. I should use debuggers more. Right. So obviously this is kind of like a weird code, but I mean, if it works, it works. So, and then let's just do that and print it. Look at that. So it actually printed this entire thing correctly. So if you take a look at the expression, we probably want to also do print f new line. So we're going to print f new line. Yeah, so this is going to do the thing. This is going to, oh my god, I'm in a different place. Okay, cool. Cool. So yeah, I think I want to make a small break. All right, so already streaming for 2 hours. I'm gonna make a small break. I'm gonna refill my cup of tea, and then after the break, we're gonna continue doing this entire thing and try to port this entire thing to WebAssembly. Okay, so we are back. What we need to do, we need to try to compile this entire thing to WebAssembly now, right? So let's see how we can do that. I already compiled C to WebAssembly in Olivet's. So let me try to recall how we did that. Oh, we even using like an old version of no build actually. So do I have Olive C actually? Yeah, so I have it in here. I should probably import it to Nob, honestly. All right, at some point. So build terminal demo. So there should be something like build Wasm demo here. So that's a pretty. I remember this syntax. Horrible syntax. Okay, so here is the flags that I usually use for this kind of stuff. So we probably want to build both of these things, the native part and the WebAssembly part. Right, so let me see. So it's going to be cmd append cmd. This has to be Clang. Since we're going to be using Clang, I think I'm going to use Clang for native version as well. So there's a common flags. What I'm thinking, maybe I want to put common flags into a separate macro, right? So let's do something like cc common, maybe Clang common flags. So it's going to be cmd, actually like this, cmd append cmd, and this is where we're going to put all the common flags and stuff like that. So these are the common flags. So the reason why I want to do it like that is because now I want to put that as a separate call. So the first thing we do, we just append Clang. Then the second thing we do Clang common flags. So it's going to be cmd like this. And then we append cmd append this kind of stuff. So that way I can abstract away certain like common chunks of flags that I put in there. So now here, what I can do that, then common flags. After that, I have to try to append target Wasm32. So after that, I'm going to output expression Wasm, but I'm going to try to compile the expression C, and I'm going to try to execute it. Obviously, it's going to fail, but I just want to see how exactly it is going to fail. So we have a bunch of flags that I know for sure work. Right, so I'm going to then copy paste them as I need them. So let's go ahead and just like try to run this entire thing, and as you can see, it fails with no stdio. Which is rather funny. So file not found, because I never said that I don't want to use standard library. So it automatically implied no standard library. So I wonder how can I check whether we are currently in a Wasm or not in a Wasm. One of the things I can do, I can basically specify some sort of flag in here. So maybe d Wasm. Maybe the target is already passed by Clang. I'm not 100% sure, but I'm, you know, I'm not gonna take a bet in here. So I'm gonna just like pass something, and with that something, I'm going to basically distinguish this kind of stuff. All right, so this is stdio. If not platform Wasm, so it doesn't autocomplete what I want to. If not platform Wasm, right, include that. So don't include this kind of stuff on the platform Wasm. So let's actually go and see what is it going to say. C type also, funnily enough, C type also doesn't exist in here. Huh. I would expect otherwise, but okay, sure. And okay, so here comes the very interesting part. So it doesn't have strings in here. Doesn't have strings. So that means we'll have to live without it. Sure, fair enough. Another stuff is that I have to say what kind of backend we're using. I have to specify the backend in here. So if defined platform Wasm use define backend. So the backend for the arena is going to be Wasm heap base. So for those who doesn't know, Wasm like a heap base. There's probably there should be an article. I keep searching for that article over and over again, but I forgot how to search for that. Programming in WebAssembly without mscripting. This article. This is a very cool article, and if you want to learn more about WebAssembly, I really recommend you to check it out. So this specific article. Right, so I'm gonna put it in here. And they talk a little bit about heap base. Yeah, so this one is rather important, and there should be yeah, there should be this picture that demonstrates what it is. So heap base is basically pointed to the place in a WebAssembly memory after which the heap starts. So if we're going to be allocating new memory, actually allocating new memory in the WebAssembly, we have to place it after the heap base. And this is exactly what we're going to be doing in here. Right, so this is what we're doing here. If we're not in the platform Wasm, we'll just do that, and so on and so forth. Okay, so let's try to recompile it one more time. So we're getting some subs. Let me actually quickly acknowledge them. So Auswader, I hope I pronounced your nickname correctly. Thank you so much for Twitch Prime. Secondary, the Sorcerer, thank you so much for Twitch Prime with a message heap based. Okay. It is in fact heap based. That is true. That is true. So it doesn't have a string, which is probably a good thing, because I'm not really sure why we depend on string in here. Do we depend on string because of the mem copy? We depend on it because of the mem copy. So I'm not quite sure. So I can try to remove the string in here and try to recompile it one more time. Okay, so we have things like strlen. Right, so we can try to, and mem copy and so on and so forth. I wonder what would be actually like a better way to approach this entire thing, because obviously in WebAssembly we can't really have any of these things, so we can try to re-implement strlen and memcopy ourselves, but not 100% sure, because like platform Wasm is a macro that I use specifically for example, but it's not for the arena. So in the arena, yeah, we do things differently. So let me try to go to nopc and let's disable building WebAssembly for now. Right, let's disable building WebAssembly for now. Right, so it wants strlen, but it wants it where? It wants it in a general sort of backend, which is basically reusable across all of the backends. So that means we kind of have to get rid of the strlen, like string. Like, okay, I can implement it myself. I can have something like arena strlen. which is not that difficult to implement. So the implementation of strlen is actually super easy, if you want to know. Const char s, right? So you do that, and essentially, so you have some sort of a counter. And then you advance the pointer, right? Advance the pointer, and then check whether you reached the end or not. And while you advance this entire thing, you basically like increment this entire thing and you return n. So that's basically what it is. If I'm not mistaken, I think that's about it, right? So that's about it. And we can even take a look at how it is implemented in Musel. Right, so here is the Musel, and we can try to find file with the name strlen, right? Because each individual function is a separate file. And okay, it's a little bit more involved, especially if it's a GNU-C. But if it's not GNU-C, its implementation is okay. That's even more based implementation, but it's kind of close, right? So you basically store the beginning where it starts, right? So this is where it starts. Then, well, bro, what you can do it with just a single while loop, can't you? Yeah, you can then do while like this, and then return s minus a. Honestly, I like my implementation a little bit better. I kind of like it a little bit better. It's more like explicit. Right, so this is going to be arena strlen, and let's continue compiling this entire thing. Let's continue compiling. So let me see. So we also have memcopy, and memcopy can be also implemented very easily. We can implement our own memcopy. Okay, so let me see. So this is the basically signature. This is basically the signature, and let's actually do arena memcopy. So we have destination, which is going to be that, and the source, which is going to be that. So, and yeah, we can just like iterate through size 0 to n plus I. But honestly, I would like to have them as you know, pointers to the character, right? So because we're going to be copying them by a character. So something like this. So it's going to be D destination and S src, right? And then effectively we can just do something like this. Right? So we're copying it byte by byte, and you may say it is slow, which is kind of technically true. But I think it doesn't matter in our case. So what does it return? It returns pointer to the destination, so we just return destination. Right, so copying byte by byte is kind of slow, but let's take a look at how Musel implements that. So that's a very interesting question, right? So Musel is kind of a production-ready library, so how does that thing implement that? So find file name memcpy.c. Okay, so how does it implement that? Okay. Yeah, it actually does a lot of involved shit. So yeah. But it only does that if what? If GNU-C. Right, if you are on GNU-C, it does some trickery. It does some fuckery. But if it's not GNU-C, it also copies. It even called them the same. It even called them D and S. Look at that. It's actually rather funny. Yeah, so it's literally copying DNS. And the reason is the same as in why that I said in the video, why is C compiler so smart? I'm pretty sure you guys all seen that video. Do you guys know what I'm talking about? There was a video that is like being viral in a tech YouTube. Dick. Holy shit. This is actually so cool. Yeah, the famous video. So for that reason, because if you're using Clang, it's gonna recognize your intent and optimize it anyway. It doesn't fucking matter. So I suppose in case of GNU-C, it's probably not gonna do that. Memcopy optimization, yeah. So it's gonna optimize that anyway, so it doesn't matter. So what you have to do to like Clang, you have to explain to Clang your intent. And the best way to explain your intent is to write as clear as the code as possible, right? So, and this is a very clear pattern that a lot of modern compilers will recognize. right? So this pattern is very much recognizable. Though I kind of like these things. So this is n. Yeah, I want to steal this code. So I want to just steal this code. Look at this code. And obviously this one probably has to be, what the fuck, const, right? Damn, broskies. Look at that code. Anyways, so we have arena strlen and arena copy, which is nice, right? So we don't depend on string anymore. So what we're trying to do now is to get rid of the dependency on string. So there we go, arena mem copy, right? So here's the arena mem copy. Anything else? Arena mem copy. All right. There we go. We don't depend on string anymore. So that's pretty cool. That's actually pretty cool. I really like that. We don't need string. So which makes it even more portable, right? Maybe at some point it's going to be usable on embedded devices. Who knows? All right. So let's go into the node.c. And I'm going to enable the WebAssembly back to back. So stdio. Okay, but specifically for that, I actually created this flag, arena no std. And what do we use in here? Oh, this one is rather interesting. Yeah. So we only need stdio for printf. But what's interesting is that if you need printf, for example, in WebAssembly settings, you can use something like stb printf. Right, so in one of the STB libraries is stb_printf, and it's actually pretty cool. I used it a couple of times in the WebAssembly settings, and it's like pretty reliable. I really recommend to check it out. So this is probably something that we're going to be using, right, when I'm going to be using Arena in WebAssembly, but not right now. So for now, if we are in the if the platform is Wasm, one thing we're going to be defining in here is arena no std. Right, so as you can see in here, we're specifically looking at the current platform, and for that specific platform, we're just defining a bunch of additional things. Might as well maybe put something like this in here. All right, so let's try to recompile one more time. Assert. Assert is rather interesting, and it's actually redefinable. So one thing we can do probably is that when we are on WebAssembly, let's just completely ignore assert, right? So we don't have any assertions, but it would be nice to maybe enable them at some point. All right, so, okay. So we reached the point where everything compiles except this part. So let's actually remove this entire part. And what do we have in here? So it complains, okay. This one is interesting. This one is interesting. So now with our example, we don't have proper not printf. So if we are platform Wasm, let's just define a dummy node print like this, which doesn't really print anything, right? So otherwise, if it's not that, we do and if. There we go. All right, so what else do we have in here? Source location. This one is also interesting. So we also don't do source location. We might as well put all of that stuff under that if. So which also probably means that this thing has to be somewhere here. So this is a source location. We can implement them later, right? So when we actually start implementing stuff for WebAssembly, we will probably need to create some bindings to JavaScript and implement some sort of a printing and whatnot. So it's a classical situation, right? So right now I'm just like removing some things. Primary, yeah. This one is a little bit annoying. We still use this printf to indicate an error, but I'm not sure how to get rid of that. So I'm just thinking, maybe we need to have some sort of like a platform printf, if you know what I mean. Like a platform printf that, depending on the platform, just like prints differently. So let me see. So fprintf, we very actively use fprintf, right? Very actively use fprintf. So maybe I'm gonna do fprintf error, std error. like this, and just replace it with simply printf. Yeah. Just don't print it to std error, just like print it somewhere. Just print it somewhere. What are other printfs we have? Okay, so I'm gonna get rid of that. I'm gonna simply get rid of that, and I'm gonna get rid of that. Right, and now, if you are on platform Wasm, we're gonna define a dummy printf, just to ignore everything, just to ignore each individual call to printf, so then we can implement it later. Right, so on Wasm it's gonna be probably calling to JavaScript function, and we're probably going to be using stb as printf to format things appropriately and stuff like that, but for now it's just going to be disabled. Right, so that's what we're doing here. Okay, what else do we have in here? Abort is also not defined, so we might as well... Okay, this is an interesting idea. For all of these functions, let's actually define them as like a dummies. Okay, unused variable n. Aha, that's really funny. Technically it is true, but this is because we ignore him. Damn! This is annoying. What the fuck do I do, chat? What the fuck do I do? I mean, it's a... well... Fuck you! Like... Can I do anything? Compiler sufficiently smart. Yeah, so can I just like void va args or some? Can I do something like that? Do you guys know? What's the usual trick in here? Left upper end of comma has no effect. Yeah, but I mean... Fuck you. Anyways, that is stupid as fuck. So we can maybe do something like this in here. I don't freaking know. But eventually, okay, so I'm gonna just ignore this warning. Is digit. Okay, so this one is interesting because C type is not available for whatever freaking reason on WebAssembly. I have no idea why, even though I think it should have been, but it isn't. Right, so we have is digit. We can quite easily do something like this. Okay, this thing is less or equal, and this thing less or equal to 9. So that's it. That's the easiest thing we can do in here. Cool. Yeah, it didn't like it. Yeah, so because of this stuff. So assert. Okay, so this is a warning. str to L. Bro. So call to undeclared identifier. So where this thing is defined, maybe we can include some of this stuff. It's a std_leap, and std_leap is not available in here. It is not available. If I try to do something like this, like we literally can't do that. Oof, oof, oof. Well, we have to implement it ourselves then. We have no choice. But we have Musel. Can we just steal some shice of... Yeah, bro. Let's like, for every standard like a libc library, we can just steal some shit from Musel. Like, I didn't think about that. This is genius. Okay, and this is what we've been doing anyway. So let's find type F. So what is it called? str to L. C. Yeah, let's fucking go. Tox. Okay. str to... Please don't tell me that... Oh, okay, so they're inter-implemented with each other. Oof, oof, oof. What the fuck is this implementation? Oh, I think I remember it. Not everybody knows that, but you can open a string as a file and read character by character. Bro, who the fuck does that? Okay. Okay, fair. We can implement it ourselves, but we need some like our own isDigit. IsDigit. I'm actually gonna call it differently, so it's different from C type in case we include C type. And we're just gonna put isDigit src cursor like this. All right. So then we're gonna return this stuff like that. We kind of need this thing. Okay. So we have isDigit. Now, while, so we need to have something like long. Yeah, let's keep it as long. So this is 0. While isDigit, while this thing is true, what do? We take n, multiply it by 10, then we take our digit and add it to here, but first we subtract 0 to actually turn it into digit, and we reassign it back to n. So maybe it makes sense to make it unsigned, just in case, and let's make it as long as possible. So it's gonna be basically wrapping around and stuff like that. Believe it or not, that is it. So we don't even have to do anything in here. We might as well also, do plus in here, but that's too much. I think that's too cursed. So this is going to be plus 1. And that's it, actually. We don't need a function. We actually made it simpler, believe it or not. So look at that. So you have some sort of a string in here, right? So, and this is a string. Then you have a number which is initially 0. So the first thing you do, you multiply this number by 10 and then add 1 to it. So you end up with, this one becomes 0, this is 1. Okay, you advance your cursor. Then you multiply by 10 plus 2. Okay, this entire thing becomes 10 plus 2, 12. Okay, you remove that. Now you multiply it by 10 plus 3. Okay, this becomes 120 plus 3, 103, and so on and so forth until you actually sort of like moved all of these characters sort of into this number. So this is how you do that. So it's a very simple trick. You don't need a standard library. And obviously it can overflow, but we can just like let it overflow. Because it's an example anyway. Nobody cares. Anyways. So let's see if it compiles. Let's see if it compiles. Okay, Boolean. I wonder if Boolean actually available in WebAssembly. So that's pretty cool. Unknown file type, blah, 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 blah. At least it compiled. It failed to link, but we managed to compile it without standard library or any of this scheisse. I think that's very fucking cool. So let me see. I suppose one of the things we have to say in here is, like, we didn't say no standard library. Look at that. We never said no standard library. So what if we say no standard library? Will that change anything? Okay. That's pretty cool. So that actually changed. So now it doesn't try to link with the standard library. Right. It doesn't try to link with the standard library. But it complains about entry. Let's say also that we're not going to have any entry. And it compiled. That's it. Oh, somebody suggests to... just a second. Do we have... Yeah. You know what? I think I can just bring the chat in here. Okay, ignore void. Let's give it a try. Well, let's see if it's going to work or not. So it has to be... So is it some sort of a GNU extension? It feels like some sort of a GNU extension. I'm not sure if it's going to work. So I'm using Clang. So did I define FMT? Anyways, so it created thing, right? So and there we go. Here's the Wasm, right? So here is the Wasm, and we can try to load it up. We can try to load it up and stuff like that. I'm actually kind of surprised that it compiled, because we don't have some things implemented, right? So we don't have a new region implemented, or do we? Ah, that's rather interesting. So maybe it expects new region as an external thing. One thing I want to do, by the way, I want to probably convert this thing to what? Let's do that from nob.c. Let's do it straight up from nob.c. Who said we can't call from C in here? Wasm to what? Wasm to what? Right, so we're gonna grab this entire thing and say, okay, so just do that, like so. So, and see, so it prints all of that stuff too. Ooh, it optimized shed out. So does that mean that its size, why does it have such a huge size then? So what's in that size, I wonder? Is that a debug information? It could be a debug information. Chat. So let's not do common flags. I kind of still don't want to have flag, like warnings and shit. I still want to have warnings and shit, but let's exclude GDB. Yeah, let's do that. So what does it say? What are you even saying in here? Ah, I probably did a fucky wacky. Yeah, I forgot the semicolon. Didn't even spend 3 hours debugging, but I mean, yeah. So now, if I take a look at this entire, yeah, there we go, 167. Look at that. Look at the size of this Wasm. Look at the size of this Wasm. So I think what we need to do in here, chat, we need to export some of the functions. Semicolon, got them. Yeah, exactly. I think the only function we need to export in here is main. All right, so we're gonna just call main function from JavaScript, and it's going to execute the example, and then we're gonna bind printf to some calls to JavaScript, which will print to DevTools. So that's basically the plan that I have. Right. So how can we export some of the functions in here? We can. So you can basically export like this. We're definitely going to be exporting heap base, right? Definitely going to be exporting heap base. But for now, I'm going to just export main, because that's the function we're going to be calling from WebAssembly. And something, now we're talking. So it tried to call to new region and it failed. It actually failed. That is cool. So, yesu. That means that we have to go to the place where we have to implement the heap base backend, and we need to stub the new region like this. So here comes the new region, and another one that it's complaining about is only new region, surprisingly. So for now it's going to be just null. And this one we can just ignore capacity. It would be nice to maybe assert, but we don't have assert in here. Okay, so it compiled. That's pretty cool. It actually compiled. And here's all of this stuff. I wonder if I can just like redirect the whole thing. Like I don't want to print it. I remember that there was a way to, you know, redirect the output. Or maybe Wasm to what actually accepts some parameters in here. Let's actually see. Does it accept anything? Output. Oh, okay. So you can just like output it somewhere. So it's going to be output build folder expr what. Okay, that's pretty cool. So that means now I can just, you know, call knob, and it, as you can see, called it, redirected, so I can now open what in here. Okay, so that's pretty convenient. So everything is like located in that folder. I really like that. It's pretty convenient. What's funny is that you could maybe run these two things simultaneously, right? So you see, the compilation of the native version and compilation of the Wasm version, they don't depend on each other. So you can kind of execute them simultaneously. So to execute them simultaneously, I think what you can do This one is not gonna work. Yeah, because these two things have to be executed sequentially, so it's a little bit, it's a no-go. Yeah, we could do asynchronous, but it doesn't matter. So the compilation is fast anyway. Okay. So now the time has come to load this thing into JavaScript. So what does it export? So it exports memory and it exports main, which is pretty cool. Does it import anything? Do we depend on any of the functions? I don't think we depend on anything. Right, so new regions doesn't do anything. Arena alloc just calls to something, so everything seems to be fine. Yeah, we need to probably export heap base because this is what we'll need in here at some point. So let's actually put it in here. So here is the heap base. And I'm gonna open what? Yeah, here's the heap base. So here's the heap base. We exported it successfully. That is pretty cool. That is pretty cool. Have you ever implemented your arenas lib in C? So, let's fucking go. We need to, how are we going to be doing that? Are we going to be doing that in the browser, or are we going to be doing that in maybe Node.js? I kind of want to do that in the browser because I think it's kind of cooler. Yeah, let's do that in the browser. So we're going to have export. I don't even know how to approach that because the Wasm module is in build folder. So it will very much depends on like how you run this entire thing. Okay, so I'm going to do run HTML, and this is going to be just like a regular HTML thing. Right? So HTML, HTML. So this is a head, title, title, exports, and then I'm going to have a body. Yeah, this I didn't mean to do that. Body. All right, so going to be h1, and in here we're going to say open DevTools console. Right. So in here we're going to have a script. Cool. So we need to do a fetch in here. I'm going to maybe use a little bit of a coil. Client MTS. Where is MTS? So where is the fetch? So we have to perform a fetch, and within the fetch, so we can set the URL to, I suppose, build export Wasm. Is that okay for you guys if we don't have any highlighting? Because it's totally fine for me, but maybe for some people it's not really pleasant. So we can do maybe like an export.js and just copy paste the stuff in here. Is that better? Like, do you guys want highlighting, or? Because I personally don't mind, but so export.js. So we can do something like this because I kind of like that everything is within the single file, right? So, but I know. So here's the fetch, and so after we fetched the thing, we need to instantiate this entire stuff, right? But as we instantiate, we also have to set up the environment. So here's the environment, and I think our environment doesn't really expect anything, so we can keep it like that. Okay, so I think we have to have like a high top level async. We're gonna just wrap this stuff in here like so. Yeah. So this is what we got, and this is the Wasm thing. So let's, after we loaded it up, let's log the whole thing. All right, that's pretty cool. So in here, I'm going to do Python 3 and HTTP server 6969. Cool. Let's open it up. We probably have to do export HTML. There we go. So what do we get? So I'm using Firefox, by the way. I'm not sure how good of an idea this is. It didn't do shit, Brovsky. How come? How come it didn't do Scheiße? Because I never called it. Okay. let's fucking go. So we got this thing, but did we ever await it? I think I forgot to await it. Yeah, let's fucking go. Okay, so we got the object, which is an instance. Okay, that's pretty cool. We don't have any experts. Well, we should have some experts. And we have main. Look at it. So that's pretty cool. We have some main. Cool. Which means that we can try to call it Wasm instance experts main. Let's first try to print this function. Let's try to print this function. Okay, it does exist. Let's call it. And nothing really happened because we don't print anything to the console. We didn't print anything. Okay, so let's go ahead and try to print something. This is going to be very interesting in my opinion, because we need to do printf, right? So we'll also do abort. What do we use abort for? I'm not sure if it's that important, but printf is more important in my opinion. Okay, so here's fmt and here's a bunch of arguments. The thing we can do, we can basically expect forward declare a function platform right, which basically just accepts the pointer to the buffer that you want to print and the size of the buffer, something like this. And the question is, how are we going to be printing all of that stuff? So we need to maybe allocate that buffer somewhere. We need to allocate that buffer somewhere. Well, we can allocate it within Arena, but Arena is not implemented yet. So that's kind of a problem. We can maybe have something like write buffer, right? So we have a write buffer. And we can have like maybe 4 kilobytes of write buffer. And what we're going to be doing in here, we're going to basically do sprintf. Yeah, stb sprintf time. Exactly. We're going to do sprintf into that buffer and then call in platform right. So that's what we're going to be doing. So let's go ahead and just bring stb sprintf. So by the way, it is so portable that it works even in WebAssembly environment. Like it doesn't use any standard library. I hope so. The last time I tried it, I think it works for me. Right. So, and I think it will work this time as well. Let's do wget and just like put it in here. Okay. So I need to probably include stb sprintf.h. Implementation. So we also have to define the implementation for this thing. Right. Okay, let's try to rebuild the whole thing. Doesn't complain about anything. That's very. It just worked. Wait a second. Okay, so stb sprintf. So where's the function itself? Is it just sprintf? Does it have a specific name or? So API stb sp sprintf. I think I need sn printf. Yeah, so this is what I need in here. So what we're doing, we're printing into the write buffer, right? The size of the buffer, we kind of know it, but we can actually do something like write buffer capacity. We can define write buffer capacity like this. So write buffer capacity, then we put fmt, and then we expand VA args in here. And the cool thing is that this function returns how many characters it printed, right? So always returns a 0 terminated. No, it doesn't. It returns int. What the fuck are you talking about? And where is it? Wait, where is it defined? It's not even searchable in here. It uses decorator stuff. Damn. Right, but anyway, so if it returns an integer, what we can do now, we can do platform right, and we can do write buffer like this, and that's it. You see what I'm talking about? But usually printf like returns number, but our printf is not going to be returning any number. So let's actually try to compile this entire thing. And what does it say? Oh shit! Fuck! Damn! Okay, so that means printf doesn't have to be a function. Should not be a function. So let's do printf. Oh damn. Well, I mean, we do have. We need variadic arguments here. But I mean, that's totally fine. That's totally fine. We can do that. We can achieve that. So here's the variadic arguments, and let's just quickly implement this entire stuff. So what we have to do is this kind of thing. So it's going to be int n, and we have to do probably vsn. So stb, yeah. So this is what we have to do in here. So vsn printf, and we have to do args in here. So the real question is, can I do include std_args? Do std_args work in WebAssembly mode? I'm gonna presume that they do, because that would make sense. That would make sense for them to work. All right, so this is gonna be n, obviously, but here we have to do va list args. And I think we do va begin fnt args. Then we pass them in here. Then we do va end args, like so. That's what we do. Interesting. So we are no longer bound by JavaScript for web things. Yeah. I think it's va start. Well, I mean, we're still bound by that. Okay. So, and this thing is supposed to return integer, like we return n. So how many characters we printed in there? Okay, look at that. Undefined symbol platform right. So what we have to do, we have to actually tell the compiler that allow undefined. So if you have anything undefined, just expect it to be provided from JavaScript. And now it compiles. So if you take a look at what now, platform right is imported as a JavaScript function. So what we have to do now, we just have to implement platform right in JavaScript. We will be given the pointer to the beginning of the buffer and how many characters we have to print. And that's the only thing we'll have to do, seriously. So that's actually pretty cool, I think. Right, so here, yeah, so let's go ahead and do that. I'm going to open this thing, so I'm gonna, yeah. So platform right is not a function. Platform right is not a function. Let's go ahead and implement it in JavaScript. So exper.js, so it has to be defined somewhere here. Platform right. So here we accept a bunch of arguments. I want to print them to console. Console log platform right, and let's actually use this stuff, args like this. So now, if everything is implemented correctly, for each individual call of printf in this example, we're going to have a corresponding call to platform right, which will print two numbers for each individual call, the pointer to the buffer and the size of the buffer. Right, so that's what we expect. That's what expected in here, at least. All right, so I'm going to recompile everything. I'm going to refresh. Okay, so this is how many platform rights we got. And it kind of, yeah, it's kind of interesting. Yeah, it basically prints individual chunks. It basically prints individual chunks of the final parsed expression, right? Because if you call the native version, so this is first chunk 1, 2, 3, 4, 5, 6, 7, 8. Well, it's actually more, right? I wouldn't say it printed. Well, okay, some of them are repeated. Look at that. Some of them are repeated. So I think it printed correct thing. So it was trying to print this thing. The problem here, by the way, the problem here is that if we're going to be perform like a single console log call for each individual platform right, each individual of them is going to be on a separate line. std out flushing, yeah, we'll have to implement it. We have to implement buffering in JavaScript. I swear to God, like I keep saying that, but everyone is thinking that I'm crazy. Web is dragging us behind. Web is dragging us behind, right? So I want to just do some web development, and now all of a sudden I'm implementing buffering, something that is implemented in libc for a long time. Like, why am I back to these times where I have to do that myself? Like, what the fuck? So inner text plus, maybe this is what we have to do, actually, unironically. That's a good idea, Angle Caro. Let's actually do that, like on the level of DOM, and that way we don't have to even like ask the user to open, things. Let's go ahead and do that. Where is my expert HTML? So okay, output. So this is that, and can I have something like code? So what's the tag that just has some code and whatnot? I think that is basically it. So can I do something like for 1 to 10? Just do something like print it. Just print it. Just print it. It's pre. Okay, thank you so much. Okay, that's actually pretty cool. Thank you so much. Okay, so we get some subs. Let me bring them in. C Sharp, thank you so much for tier 1, and Black Haze, thank you so much for the try with the message. Happy. So thank you so much. I'm sorry. Okay, I already streamed for more than 3 hours. Okay, cut me some slack, so I'm going fucking insane. So this is where we're gonna be doing all of that. So this is gonna be the ID, log, and this is where we're gonna be appending shit. Let me see how we can do that. Can I think I can do something like that. So console const log document query. I think it was get document by ID, right? So get element by ID, query selector. I mean, bruh, I have ID. Document get element by ID log. Yeah. Oh, it even highlights that. How about that? Can your Chromium do that? I think it can, actually. So, and in here, we can do something like log inner text plus, like this. Okay, look at that. So that kind of worked. We can even put new line here. Can we put? Yeah, look at that. Look at that. Isn't that poggers? Isn't that fucking poggers? Fucking poggers. Poggers. Okay. Cool. So now we need to have an access to the memory, right? So to get an access to the memory, I think we need to initialize it with null first. And as soon as we get something, right? So we have a memory in here. Though honestly, can I have an access to Wasm from within the environment? Can I just do console log Wasm like this? I feel like I can't. At least I don't see the Wasm in here. Yeah, I think it cannot see that shit. One of the things we can do, okay, so let's actually define Wasm like this, and let's put it like this. Then I can... you don't... fuck, I forgot, yeah. Okay, just a second. Wasm instance exports main. Let's go. Yeah, boy. Okay, that's cool. So we have a Wasm log. So instance exports memory. Okay, what do we have in here? So here's the memory, and there should be some sort of a buffer, right? So within, yeah. So here's the buffer. Cool. I do the buffer. That's pretty cool. So this is a buffer. And now I can take a view on that buffer. So I can do uint8 array. And what I have to provide in here. So first one, is the pointer to the buffer and then the length. So what I can do, I can just do something like buff len. So args is not defined. What the fuck are you saying? Because we don't have them anymore. So we can actually kind of get rid of this stuff. But we can... So we can define this as a text and just print this text in here. Yeah, look at that. Look at that. So here are the bytes of like what we need to print in here. So here are the bytes. So we now need to convert them to string. So there should be some sort of like a text encoder or whatnot. Console, actually JavaScript, uint8 array to string utf8. So text decoder, text encoder, something, something, don't remember. Yeah, so let's have, and it expects you to create text decoder every single time. I think it's kind of stupid, but we can do that honestly. New text decoder, and then we just decode. I'm gonna fucking decode. I'm gonna fucking decode. Anyways, so okay, so now what we can do, chat, we can just append the text. There we go. So we ported example. How the fuck we did that? We didn't even implement new region. Wait. Who needs memory safety when you can actually write to null and corrupt the beginning of your... Holy shit, bro. We didn't implement this thing, it just worked. So that means usually Clang, when it generates code, it puts some like necessary data at the beginning of the memory, starting from 0 and stuff like that. So what this thing did, I think it literally just overwritten itself several times. Can your Rust do that? Can your Rust do that? I don't fucking think so. Rusticians are molding. Rusticians are molding. So let's actually see what else can we do in here. I actually want to print more things. So this is the source code. I want to print two things. First one, I'm going to print source, which is going to be S, and it's src begin. So this is the source. And then we're going to do the second thing. This one is interesting. If expr is null, we're going to say, I think what we have to do, yeah, so we just have to exit, right? We're going to exit with return 1. Otherwise, we just start printing AST. AST is that, but we don't even have to put a new line in here, we just have to put space in here. All right, so I want to recompile the whole thing. Yeah, so it's going to be nub. So just a dot. Okay. It's pretty cool. How can I get rid of this scheiße? How can I get rid of this scheiße? I kind of don't like it. So expr HTML. Do I do something like a style margin left 0? Don't put on... I see. Boom. Yeah. That's pretty cool, I think. I think that's pretty cool, chat. I think this is very fucking cool. So now we can even introduce some sort of a compilation error, a parsing error, I would even say. I'm gonna rebuild this whole thing. I'm gonna run a native version. Okay, native version kind of ignored this shit. So we can just use maybe a slash in here. So it's gonna be num. Yeah, and now it tells you that there's something wrong. Now look. It does the same shit in WebAssembly. And we didn't even use mscripting, chat. We didn't use mscripting. We just re-implemented like a small portion of the standard library, including printf. Well, I mean, we used stb as printf, but I mean, still. How fucking cool is that? Mscripting who? Who needs mscript? Like, seriously. Yeah, so just like implement functions of the libc that you use. And you don't use the entirety of libc anyway. Do you use the entirety of, like, why do you need the entirety of libc? That's pretty cool. That's actually pretty cool. But again, the arena is not even fucking implemented. So I suppose the thing is that, like, you can just write into null, can you? Or can you not? Like, what the fuck? Ooh, you know what? So when I call new, usually in all of these places, when you call new region and it cannot allocate anything, it just crashes. But we also don't have any asserts or anything, so it never kind of never crashes. All right, so let's go ahead and try to maybe implement some stuff. Let's try to implement some stuff. So we need to have pointer to heap base. How do we do that? So stack grows downwards and heap grows upwards. Cool. Some examples. So we're supposed to actually do this kind of thing, right? So extern unsigned char, blah, 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 blah. Right, and when you take a pointer to the heap base, you actually take a pointer to the heap base, that place in the memory. So let's just copy paste the whole thing in here, right, and put it in here like this. And now we're going to implement it as a bump allocator. Right, so this is going to be the bump allocator. Let's go. Okay. New region. And when we allocate a new region, like, what exactly do we do? Aha, so this one is interesting because capacity, this is not in bytes. This is in words. Right, so this is in words. So we have to first compute the size in bytes and only then allocate it, allocate it there. So here's the capacity, then size of the word, and then size of the region. We combine them together. So I think I can do size t. So and after that, right, I just do. This is a really weird way of doing that. Well, I mean, maybe that's fine. Right, unsigned int. Where am I? Oh, okay. So unsigned int r, bump pointer. Maybe I'm gonna actually put a link in here. Stolen from here. So this is a bump pointer. After that, we increment bump pointer by size bytes. And honestly, since we already use size t, who said we can't just call it size t here? I think it makes sense. I think it makes a lot of sense to call it like that. Bump pointer. Is that a good idea? Maybe. I'm not sure. And then we just return r. Anyways, this is stupid. This has to be void star. Like, this code is stupid, by the way. I'm not gonna even credit it. Well, I mean, I'm still gonna credit it. Right. So this is just a void star. But I mean, it has to be. Yeah, it's better for it to be unsigned char like this. All right, and then when we allocate in a region, this has to be a pointer to the region. So then we do it like that, then the amount of bytes, and then we're, okay, so that makes more sense. Okay, so that makes more sense. I think it makes more sense. So when we're implementing, we also implementing free region, but we never really do anything with the free region. So we're gonna just ignore this thing in here. Right, so we never free it. We never free it. Okay, so yeah, incompatible pointer, but it's a bump. Yeah, okay, so I'm gonna convert it to void star. All right, so that seems to be working. That seems to be working. And now, if I try to refresh my thing in here, index out of bounds. Oh, so it broke. That is so cool. So yeah, so it couldn't grow any further apparently. So we try to allocate more like access memory after the heap base, right? And then it's just like it couldn't do that. You segfold? Yeah, I segfolded. I didn't segfold before because null, but now like, but maybe I have to just like have a bigger memory. Maybe I just have to have a bigger memory, or maybe not. What if I? Well, yeah, I do export memory, but how can I make memory grow automatically? Is there anything about that in here? I kind of vaguely remember that I have to do something with the memory, but I don't remember what. So yeah, this is accessing the memory. So we don't provide anything. Buy more RAM, lol, exactly. Exactly. Yep. So let me take a look at what does it say. Index out of bounds. Export, and it's somewhere. Doesn't it tell me where? I should have not implemented, honestly. Should have not implemented the new region because that should work before. More 64K pages needed. Yeah, exactly. I don't remember. So I remember in Jai. So maybe we can steal some code in Jai. Let's see. So there were some examples. Wasm. And one of the things I remember they were enabling. So first, so bulk memory. So LM options, target system features. The option is needed so that memcopy and set are mapped to memory copy. Oh, this one is interesting, but I don't think it's what we need in here. I want to take a look at the memory. So when I load my expression.js, I want to console log Wasm just to inspect that specific instance. Let's inspect that instance. What's interesting we have in there? So here's the instance. Experts, please load up the experts, please. So here's the memory, and within the memory, the buffer is kind of okay. So there is a function grow. All right. So there is a little bit of a memory, but then it probably doesn't allocate anymore. Probably doesn't allocate anymore. So what if I want to take a look at what's the value of heap base. So if the size of this thing is that, what's the value of heap base? So here's the experts. I didn't see, where's the heap base? Okay, so here it is. Value, please load up the value. 7240. Okay, so there is a little bit of the space, right? So if you find the difference between 7040 and this one, there is some space. So maybe it's just allocating too much. Right, so if I take a look at the 13072, so let me put this stuff in here, and 7240. This is how much it this is how much you can allocate essentially, right, until the end of the page. But how much space do we have? Write buffer capacity arena. Did we modify the arena capacity? Arena. So it's 8 kilobytes. It's not even 8 kilobytes, by the way. It's 8 words. And I suppose a word in WebAssembly, 32 bits WebAssembly, is 4. So that means it's 8. And also multiplied by 4. So this is how much of a single region we're allocating, which is probably bigger. Well, not that much. Right. So not that much, I think. So heap base is generally 1 page plus change. So maybe we're gonna like make it like a very small. You can give initial maximum props to Wasm memory. I probably can, like I don't know how to do that. So I almost done, and I just wanna, you know, be done with that. All right, so can I just like allocate them smaller? Can I have like a smaller things? All right. So yeah, so I just made the regions smaller, so it fit into the page and everything's fine. So as you can see, it's working. We can maybe explore some of the things in here, right? So we can see how many pages we have. So expr C. So first of all, let's actually make it, you know, compilable and stuff. Right. So this seems to be working, and now. What we can do, we can maybe print. So we can count how many pages we have in here. All right, so we can do n0, and then for, I think it's a region. Is it still called region? Yeah, it's called region. Iter equal to the experts. What's the arena called? Arena nodes. Yeah, nodes. Begin, while iter not equal null, we're just doing iter equal next, right? And then just do +1. So allocated arena allocated ZU pages. All right, 1 pages. 6 pages. That's very interesting. Why did it allocate so many pages, even though? So, and for each individual of them, we can do something like page. Here we can print the capacity and count. Right, so it's going to be iter capacity iter count for each individual page. So this is that. All right, so that's fine. So that explains it. I think that straight up explains it. I forgot to fill in the regions. After you allocated the regions, dummy, you have to set their capacity and count. Oh my god, I'm so stupid. Anyway. All right, so that was a bug on my part. Of course. It's not enough to just allocate the shit. Bro. Yeah, so next has to be null, count has to be 0, capacity. Okay, fine. I fucked up a little bit. Fine. So let's try to recompile this entire thing, and now if I refresh, everything is correct. Everything is correct. I really allocated 1 page, so it was just like returning garbage. All right, so that's actually on par what we have in a native version, right? So native and web version basically print the same thing, and I'm super happy about that. So that means we can actually bring back the default thing. Right, so where's the default thing? Region default capacity. So what was that? 1024, right. So let me double check. Default, yeah, so this is the default capacity. So 1 pages, capacity is that, count is 15. Everything fits perfectly. We implemented it. So the example works identically in both native x86-64 and Wasm 32. Wasm 32. Right. So, and what's interesting is that this is actually different amount of bytes, because count and capacity is in words, but word is actually different. So we can actually take a look at that difference. X per C. Yeah. So So let's say bytes. So in here we're gonna actually multiply these things by size of uint pointer and this thing. Right. So in native, this is how many bytes we have, and this is how many bytes we allocated. Okay. So in here, actually twice as less, because it's 32. And we allocate and we actually count in words. So word in WebAssembly 32 is 32 bits, in x86-64 is 64. That's actually perfect. That's exactly what you would expect. This is so fucking cool. Wasm is 32. Yes, Wasm is 32. You can actually maybe compile it to 64. Let's actually try to compile it to 64. So recently, 64, Wasm 64 became sort of like a widespread. Let's try to compile to 64. Okay, there we go. Oh my god. So cast to smaller integer, that broke stb sprintf. Well, there is a reason why Wasm 64 was experimental for so many years. Damn, like, holy shit. Web is so fucking broken, JavaScript specifically, that I'm pretty sure Wasm 64 will never be a thing. And Wasm 64 is slower, yeah. It's just like, it's insane. I think it's unsolved computer science problem to have 64-bit addressing in a browser. Which is fucking good, because that only proves that web is a toy platform that is not suitable for general purpose applications. Right, so because web sort of have this sort of, how to say that, ambition to be all encompassing platform. It is as general purpose as native. And now it finally hit the ceiling. Well, if you want to address more than 4 gigabytes of memory, you have to get out of the web now. Yeah, so it finally, it's toy scripting language finally hit its ceiling. Yeah, and this is so fucking funny to me. Like, it's so fucking funny. Like, as soon as there is some problems of actually bringing Wasm 64, the Copium started to roll in. The Copium, you don't need more than 4 gigabytes. 4 gigabytes of memory is out to be enough for everybody. You don't need more than that. I absolutely, yes. Keep the Copium rolling. Keep the Copium rolling. Web is a toy platform. Web is a fucking toy platform. Yes. Keep the Copium rolling. Oh my god. So anyways, I think we did it. So I did exactly what I needed to do today. I ported my Arena allocator to Wasm, right? So, and I can finally use it in my web applications. One more tab, yeah, just one more tab. You can have several WebAssembly instances, right, if you need more memory, which means that they don't share any memory, which means that you have to send messages to communicate between them. So thank you so much, Rodrigo Calderia Lima. I hope I pronounced your name correctly. Thank you so much for Twitch Prime. Trickery89, thank you so much for Twitch Prime. And Felix, thank you so much for Twitch Prime. Really appreciate that. IPC between browser tab is crazy, lol, but that's what you have to do, because you don't need more than 4 gigabytes of memory anyway. So yeah, that's it for today. thanks everyone who's watching right now. I really appreciate that. I didn't want to do that. Have a good one, and I see you all on the next recreation programming session with Mr. Azozin. Let Mr. Azozin switch the scene. I love you all.